Good morning.
Very good morning.
Good morning. We have started. There are a large number of people who are going to join us. So we are a little early.
It's fine, Dr. Suchitra, Dr. Rawal Singh this side from
Oh,
Amritsar.
hello.
So we are here, no issues. So
Yeah,
for
we
this,
are here and we are all ready. So we're very excited about this program because we
Yeah.
really feel that we have to work on the environment.
Yes, right. Of course, yes. Right.
Yeah, we are very fortunate that we have got this opportunity with Ministry of Environment. They've asked us to do some things. I'm
Okay.
not sure whether you're aware about Construction Industry Development Council.
Yeah.
Okay, so we are doing many things. This is one such thing that we've been doing the whole year.
Right.
We've done lots of workshops. We have done what I would say study, written report. So it's interesting.
Nice.
Yeah.
Good to see you. Right. Thank you. Thank you for inviting me.
And what about you? I'd like to know about you. What are you
Yeah.
doing?
I'm Dr. Rawal Singh, and currently I'm teaching in Guru Nanak Dev University, Amritsar,
Okay.
in the Department of Architecture.
Oh, that's very interesting.
Yeah.
So,
My
you're designing
university
houses?
is built histories. Sorry.
You must be designing houses?
Yes. So my primary research area is built histories. So
Okay.
I did my PhD on evolution of Sri Harmandir Sahib, that is Golden Temple.
Oh, wow. Very interesting. I'd love to read it. I have not been able to visit the place. I don't know when I'll get the opportunity. And I
Sure. You should.
know
Yeah.
about it.
You
Yes,
should.
I'm very
Sure.
interested in that.
Most welcome to the city.
Yeah. And today we're going to have things on green buildings and passive cooling. It is ozone depleting substances that are causing all these
Right.
problems. So that's
Right.
our focus area today. So
Right.
I guess Mr.
Good.
R.
Very,
Suresh
very.
wants to say something. The hand is risen. Can I invite Mr. Suresh? Hello, good morning. Or we'll wait for some time. Oh, Miss. Dr. Nimalam Khandelwal? Dr. Khandelwal? It's nice that you've joined, and I'm also very glad to have Mr. Radhe Agrawal with us. Good morning, sir.
Good morning, madam.
Good, man, sir. Very good.
वीडियो को सेव करने पर
Good morning, Dr. Suraj.
Good morning, Shukta-di. I can't hear you, Shukta-ji.
Okay, I think.
Now I can. Good morning.
Yeah, good morning. Can you hear me now?
You're loud and clear, Thank you. Thank you.
We meet
Good to
again
see you early.
online.
Good to see you early in the morning.
So, are you coming to Delhi for our
I
next
am.
conference? Oh,
10th
that's
to 12th, I'll be taking part
Yes.
as and when possible. I'll be there. I made a commitment to Dr. Saab. I'll try and keep my commitments, madam.
Professor Jagdish Gujral, welcome.
Thank you, madam. Thank you.
अनम्यूट रखना पड़ेगा
Thanks for the participants to join. Dr. Surup is also good to join.
अनम्यूट कर दे
But I can't hear you. I'm just asking my engineer to do that. Yeah, आवाज क्यों नहीं आ रही है? ये पिछली बार भी दिक्कत हो रही है. क्या problem है?
Okay. Can you hear me now?
Yes, madam, you are audible.
Thank you.
उस दिन ये दिक्कत आ रहा था.
आपका भी माउस कनेक्टेड है ना?
हाँ, disconnect करो. Zoom में जाओ.
हेलो
मैंने को बोलता हूँ. Just tell her. Hello, ma'am. Can you hear us?
Yes,
you are audible.
Okay,
Yes.
okay. Good morning, everyone.
Good morning. Welcome to the program. We'll just wait 5 minutes more. And Dr. Surup would be joining soon.
Thank you. Sure.
Hello.
Yes,
Hello.
Mr. Chandrakant.
Good morning. Good
Good
morning, Dr. Kumar.
Good morning. Very nice to see you.
Thank you. Fine, thank you.
This platform has made it very convenient. We can do programs even without traveling,
Yeah.
exchange ideas.
Yeah.
But we are also having a physical conference on 10th to 12th.
10 to 12 today?
No, in 10th April to 12th April in Delhi.
10th April. Okay. I will. Where is the venue?
It is in Tulsa Institute, ICAR Hall.
Okay.
There we are also going to have exhibitions, and we're doing it in a big way. Our
Okay.
Vit Sharma Awards are also part of it.
Okay. I will definitely join.
That would be very nice. We're taking advantage of both the methods. Physical is
Okay.
different.
10th,
But
10th April. Okay.
Corona has given us this opportunity too to meet online.
Okay.
Very nice. I see here Mr. Abid Hassan. We met earlier in a training program.
Yes, ma'am. Good morning, ma'am.
Good morning. How are you? In the car, I guess.
Time. What about you, ma'am? So now I am traveling, so I am in meeting.
Yes, I understand that.
Hello, good morning, everyone.
Good morning.
This is Ahmad Umam from Rambol, India.
Okay. Welcome to the program. We'll just start in 2 minutes.
Okay, ma'am. Thank you.
Hello.
Hello. Your voice is not clear, Dr. Sheikh Samir Ali. So now I would like to bid everybody a very warm welcome to this conference. It's an online conference. It is good management practices for energy efficient buildings by introducing passive cooling designs to reduce operational cost, improve health and comfort, and promote the use of non-HCFC and low GWP alternatives. It's being conducted by Construction Industry Development Council under the aegis of Ozone Cell, Ministry of Environment, Forest and Climate Change. As you know, we are all very concerned about the increasing carbon footprints adversely impacting our environment. One crucial protocol, known as the Montreal Protocol, aims at phasing out ozone depleting substances from all walks of life. Construction industry is one of the major users of such substances. And under the agreement, the nation needs to change over to using non-ODS substances. Ministry of Environment and Forest has given us the mandate to share this information with the industry constituents and facilitate this change. And not only the online things, we have done a study and found out what the status was and what needs to be done on this thing. We have conducted sensitization interactions and surveys, and 6 information dissemination workshops, which is with all the stakeholders. And now, in this conference, the pertinent issues linked with good practices for passive cooling and hydrochlorofluorocarbon phase-out management plans for the construction industry would be highlighted today. Our experts today are Professor Radhya Agrawal, Shri Vikram Murthy, Shri Akashdeep, Mr. Arop Sarup, Dr. Ruchi Srivastava, Professor Jagdish Godial, Shri Ajay Ratan, and Professor Niranjan Sur, and Dr. Neelam Satyam. And now I would like to request to start the program. I would request our Director General, Dr. P.R. Sarup, to welcome all the participants and give the opening remarks. I invite Dr. Sarup.
Thank you, Dr. Kumar, the esteemed speakers here, and all the participants. This is a very important deliberation that is going to take place today, because it basically serves 2 purposes. Number one, we have been having number of deliberations through 6 of the workshops that we had conducted. There are many issues that have been highlighted and views that have been articulated. And one thing which is very evident is that there is a definite need of stock taking. So I think in this particular assembly, we shall be basically taking the stock of the things as they exist today. So that is one very major purpose of this assembly that we have today. The second important issue is that having deliberated for over a year now, here comes the big question that what exactly is going to be the next step? Because the identification of the weaknesses, the kind of handicaps that we have, and the kind of solutions that are needed to be implemented, those parts are identified and flagged. Now it is the time that all the stakeholders, and when I say stakeholders, I mean to say construction industry captains, the regulatory agencies, like you have our ministry, you have research laboratories of various institutions, the research scholars that you have there, and who are working on several issues, of course, in a kind of a piecemeal manner. Can we bring that together and we can basically put up a project implementation plan? Those of you who had gone through the report that was unveiled by Honorable Minister of Environment and Forest a few months ago would have noted down that there is a broad outline of the project implementation plan that has been put in there. Under this particular plan, the idea that is that this is the time that in order to be honoring the commitments of Montreal protocols and the kind of standing that Government of India has been taking very aggressively to become leader of the world for that matter, I think in all seriousness and earnestness, we have to look at the PIP, the project implementation plan that has been put in there. So those of you who have not gone through this project implementation plan can definitely ask our secretariat. We'll be very happy to share a copy with you. And those of you who already have got a copy, they certainly can go through the whole thing and make sure that a lot of intellectual contribution is to be made so that we can make the whole PIP operational. My request to Ministry and Honorable Minister also is that let us not basically leave this whole effort just kind of a one-on, one-off exercise. There is a definite need of implementing certain things that have been found out to be executed and done, and we have to basically start working at it in right earnest now. So I hope in the coming years there's going to be a wonderful time when we will be not only able to kind of honor our commitments that we have made on the international fora, but also try to kind of put a project in motion within the country so that very proudly we can come out and we can one of these days claim that we have zero carbon footprint or nearly absent carbon footprint. So there is a great assembly of very wise speakers who have lifetime experience and many suggestions for all of you. And I'm very sure that today's deliberation are going to be very, very useful, and they will help us to achieve the objectives that we have there. So with that, I thank you so much once again for joining. I thank the speakers to be here to share their views and articulate the kind of things that need to be done, and others, and especially the institutions and colleges who have actually come to join us and who have been grooming the young engineers who are going to get into this world of engineering and technology and execution of project. They should be in a position to imbibe certain values and basically put them for implementation. So thank you so much. God bless us all. I hope the deliberations will be very useful. We'll go through that. And just to let you know that CIDC is also holding a very major event on 10th, 11th, and 12th of April. I'm very sure during the day, Dr. Kumar will basically make a one or two slide presentation about the event, and you will be having an idea. Please have a look at that and try to participate in this event. This is going to be very important, where we are going to be deliberating the issues and the project implementation plan that has been designed so far to put it up to the construction industry so that we can, in real sense, make sure that it is put under implementation. Thank you so much. God bless us all once again. And I think let us proceed with the speeches of our honorable speakers. Thank you so much. I return it back to Dr. Kumar. Thank you.
Thank you, Dr. Suru. And sure, we will share the information about the conference on the day. And now I would like to invite Shri Aditya Narayan Singh, who is the Additional Director, Ozone Cell, Ministry of Environment, Forest and Climate Change, Government of India, to give the keynote address.
Thank you, madam. I'm audible?
Yes, you are, sir.
Dr. P.R. Sarup, Director General, CIDC, participants from architecture, engineering colleges, urban planning policy makers, architects, building developer, building development association, distinguished participants, ladies and gentlemen, good morning to all. At the outset, I would like to extend my heartiest warm welcome to all of you for participating in the National Workshop on Good Management Practices for Energy Efficient Building by introducing passive cooling design to reduce operational cost, improve health and comfort, and promote use of non-SCFC and low GWP alternatives under SCFC phase-out management plan in India. And I would also like to congratulate CIDC for organizing this important workshop. And I am pleased to inform that Ozone Cell MOFCC has partnered with the CIDC in December of 2021 to carry out a study on good management practices to sensitize both construction community as well as the user towards the benefit of energy efficient buildings by introducing passive cooling design. And with pleasure, I want to share with you that CIDC has completed the study report on sensitizing building construction community on passive cooling design. And the study carried out by CIDC highlights some of the best available policies for incorporating the passive cooling technologies. And the study finds that the overall gaps vary from 31% to 91% in the construction community on awareness on passive cooling in building design, which clearly indicate that there is a need for intervention to improve the awareness and in-depth understanding of various processes and elements of passive cooling. I think there is some background noise. Madam, can you look into this?
No, we cannot see the slide. We will ask the person to share, give you a slide sharing. Just a minute.
No. Actually, there is some background noise between the talk.
Please make all them all mute, man.
Yes, we will give the instructions. Sure.
I was sharing that the study carried out by the CIDC highlights some of the best available practices for incorporating the passive cooling techniques, and the study finds that the overall gap varies from 31% to 91% in the construction community on awareness on passive cooling in building designs, which clearly indicate that there is a need for intervention to improve the awareness and in-depth understanding of various processes and elements of passive cooling. And the study suggests that there is a need for revision of curricula of architecture, engineering, diploma, ITI, vocational institution, etc., with the objective to provide knowledge of design of energy efficient building incorporating principles of passive cooling and environment friendly building materials. As Dr. P.R. Sarup mentioned that the CIDC has so far organized 6 regional awareness workshop for creating awareness regarding reducing the cooling demand by incorporating the passive cooling strategies in the building construction project. And in this series, this will be the last of the workshop being organized at a national level. And some suggestions as highlighted by Dr. P.R. Sarup in his opening remarks are well noted and will be taken up appropriately. I want to share that the role of ozone cell MOFCC is to implement the provisions of the Montreal Protocol for phase out of ozone depleting substance to protect the stratospheric ozone layer. And as most of you may be aware, the Montreal Protocol on substance that deplete the ozone layer is an international environmental treaty to protect the stratospheric ozone layer by phasing out of production and consumption, including uses of chemicals that deplete it. India, as a party to the Montreal Protocol, is mandated to phase out substances that are controlled under the Montreal Protocol. And after having successful phase out, the production and consumption of the chlorofluorocarbons, carbon tetrachloride, halones, methyl bromides, and methyl chloroform for controlled uses as per the Montreal Protocol phase out schedule. And the currently SCFCs, that is known as hydrochlorofluorocarbons, are being phased out as per the accelerated phase out schedule of the Montreal Protocol. And India, as a party to the Montreal Protocol and having ratified all the earlier amendment adjustment to the Montreal Protocol, also ratified the Kigali Amendment to the Montreal Protocol during September 2021. And HFCs are a chemical which have no ozone depleting potential, but have a high global warming potential. And as per the timelines decided under the Kigali Amendment, the HFC phase down schedule applicable for India is 10% from the baseline production and consumption of HFC in 2032, and 20% reduction in consumption and production in 2037, 30% in 2042, and 85% in 2047. And government has decided that the national strategy for HFC phase down is to be developed by 2023 in consultation with the industry stakeholders. I would like to share that Ozone Cell MOFCC in association with TERI has conducted a study on reduction in greenhouse gas emission through ozone depleting substance phase out under the Montreal Protocol implementation in India. And as per the study report, it has been estimated that the successful implementation of ODS phase out in India through the Montreal Protocol implementation will contribute to GHG emission reduction in the range of 778 to 1,176 million tons CO2 equivalent by 2030. And as most of you are aware, India is one of the first countries in the world to launch a comprehensive cooling action plan, which has a long-term vision to address the cooling requirement across the sectors, including in residential and commercial buildings. In 2017, approximately 272 million households were estimated in India, which will increase to 328 million and 386 million in 2027 and 2037 respectively. And the commercial sector floor area is expected to grow around 1.5 to 2 times in the next decades, and 2.5 to 3 times by 2037-38. The ICAP also estimate that aggregated nationwide cooling demand in tonnage of refrigeration is projected to grow 8 times by 2037-38 as compared to 2017 and 2018 baseline, out of which the building sector cooling demand shows the significant growth at nearly 11 times. And the intervention scenario in the ICAP suggests that through proactive measures, the total refrigerant demand can be reduced by 25 to 30% and cooling energy requirement by 25 to 40% respectively in the year 2037-38. A tonnage of refrigeration reduction potential is around 13% could be realized through more rigorous implementation of energy conservation building code in the upcoming commercial buildings in the country. Ministry of Environment, Forest and Climate Change has developed and launched an action plan for implementing the recommendation of the India Cooling Action for the thematic area space cooling in buildings, and being the most important and which can significantly contribute to achieving the set goal in the ICAP. And various government department agencies have been identified to implement the action points with respect to wider adoption of ECBC commercial, and awareness campaign to sensitize both construction community and user regarding the efficient building retrofitting, retro-commissioning, and promotion of use of not in kind technology, DCS, solar vapor absorption, chiller, tri-generation, etc. And this action plan is available on the website of the ozone cell. As you might be aware that the growth in space cooling demand have been rising steadily over the last decade due to the combination of factors such as a rising population living largely in tropical climate with growing aspirational needs fueled by sustained economic growth over the last 2 decades. And buildings represents a dominant share of India's overall cooling demand. And India is also seeing one of the fastest construction growth worldwide. In view of the rapid increase in building stock and the associated air conditioning area, it becomes increasingly important to reinforce the need to build in strategies and intervention to reduce the need for active cooling in buildings. And a thermally comfortable building design is not only important to achieve reduced cooling requirement, but also from a climate resilience perspective. And the intensity of the air conditioning demand and corresponding electricity consumption intensity in the commercial building sector is significantly higher as compared to the residential sector. And the commercial sector has been classified under 8 major segments: hospital, hotels, restaurant, retail, office buildings, education institutions, assembly places, transit buildings, and warehouses. And it's to be noted that the building design and construction can enhance the comfort level considerably if built in a climate sensitive manner. National Building Code, building bylaws, and various green building rating system lays emphasis on building sustainably by integrating climate responsive design elements which are low cost and energy efficient. These energy conservation building code, residential and ECBC commercial focuses into designing an energy efficient envelope which helps in reducing heat transfer through envelope, thus enhancing the thermal and visual comfort. And efficient or passive building design can reduce the overall heat gain in building, thereby significantly decreasing the cooling energy demand as the need for an air conditioning system to reject this heat from conditioned space reduces. Building codes have an important role in the advancing the adoption of efficient building practices, and adoption of ECBC will assure appropriate insulation inherently reducing the cooling need of the new building. And some of the feature can reduce cooling load, such as improving the insulation by increasing thickness and R value of the envelope to reduce cooling load up to 8%. Measures taken for roof insulation by installing cool green roof will reduce solar heat gain due to increased reflection and evapotranspiration. And window attachment like blind, screens, films can also use to reduce the ingress of solar heat. And building orientation and window to wall ratio can refrain direct heat gain in building indoors, thus reducing the cooling demand. The energy efficient and upcoming building infrastructure plays pivotal role in addressing the challenges associated with growing electricity demand in cities and urban areas, where more than 50% of electricity goes into space cooling during the peak summer months. Cooling Action Plan provide a tool for bringing in sustainability paradigm to a large logistic issues in terms of technologies, energy efficiency, maintenance to end, code through real-time monitoring technology, resulting reduced food loss, and implementation of actions emerging from ICAP shall significantly contribute to India's climate action, including in achieving the NDC and net zero emission pathway by 2070. And we are working on several other important issues and would like to actively associate with CIDC for creating awareness among the construction community. And with this word, I once again extend a warm welcome and look forward for successful outcome from this workshop. Thank you.
Thank you, Mr. Narayan. Really, we are also enjoying working with you, and we look forward to more such programs to create the awareness and have a real impact on the ozone depletion substances. In our future programs, in this program also, we are having a few lectures on passive cooling design so that we don't have to really cool the airspace. Thank you, sir.
Thank you.
And now to move on, I would like to invite our expert, Professor Radhe Agrawal, who is the technical advisor to UNDP and Ozone Cell on Montreal Protocol. He is also the chairman for various international and national organizations and academic societies, including chairman of one of the sessions of ECBC in 2017. So I welcome Dr. Agrawal for his presentation. Welcome, sir.
Thank you, Madam, for giving me this opportunity to speak on this occasion. That's a very well attended. I see about 158 participants to this meeting and very distinguished participants. I'll just share my
Pleasure to
presentation.
listen to you, sir. Always a pleasure. Please continue.
Is the presentation visible?
Yes, it is, sir.
Thank you very much. So this brief presentation is what actually Mr. Aditya Narayan has shared. I have just elaborated it a little bit more. It's basically on the cooling demand reduction by building design and especially the passive cooling by passive cooling methods, which are very important and easy to do or easy to incorporate in the building designs, and by which the cooling demand can always be reduced and without sacrificing on the comfort level. As all we know that the cooling is increasingly becoming important for health, productivity, and well-being of the people. Of course, there were days earlier when the cooling was not recognized in this fashion and we were living, and still our large population is living in conditions which are not healthy environment as well for living as well as for the working. So this will continue to grow, and of course the rapid urbanization and rising in per capita income. These are also, there is a demand of the active cooling systems. And if we see the active cooling systems, which are refrigerant based, and these technologies, all cooling is catered by these systems. And these systems are very energy intensive and consumes so far using the refrigerants like which were responsible for the ozone depleting, and now of course global warming, and we are trying to reduce or phase out of these ODSs, as well as reducing slowly or gradually the use of high GWP refrigerants. This actually graph shows the ICAP, India Cooling Action Plan, which was published in 2019 by the Ministry of Environment and Forest and Climate Change, and where we estimated the growth in the cooling demand and in various sectors, sector-wise. The right-hand side of this bar chart shows that there is a continuous increase in the demand of cooling, and we collected this data way back in 2017-18, and I'm happy to see that in 2022-23, more or less the matching demand is, or the estimated demand is matching with the current demand. So the estimates were very, very, reasonable. And we see that blue color shows the growth in the space cooling. And the space cooling amounts about the 75% of the total cooling requirement. And one more thing in this may be noted, that almost 60-65% need of this cooling is met by the individual air conditioners or room air conditioner, what we call a split or windows. So this is where, and which are all air cooled systems and consumes a lot of energy. And now this shows actually what air conditioner stocks we had, how it is going. In 17, it was about 35 to 40 million units, and now actually currently around 50 million units. And this will grow by 2037 to 38, something of the 350 million units or so. Of course, the left-hand side shows what is the penetration in the rural areas as well as the urban areas. Of course, urban areas have little higher, but definitely this level of penetration is still low, and that's how actually this will continue to grow in this sector. And this can be, constrained only by, what we are talking today about the passive cooling methods we use in the building, that will not only reduce, the cooling demand in that, but also reduce, the cooling days. That means the uncomfortable days may reduce by the use of the passive cooling methods. I was just looking at what is happening globally, from I could get that information that is since 1990 till 2050, we say globally, the room air conditioner stocks are growing very sharply. And if you see from 2020 to 2050, it is going to grow further with a higher growth. And in this, out of almost 550 million, hello, out of 550 billion units will be there, 5.5 billion units will be there by the end of 2050. And India will be contributing something of the order of 1 billion units in this stock of room air conditioners, which is quite alarming. And this correspondingly shows the refrigerant consumption. Currently in 2022-23, which we are there, is almost about 40,000 metric ton consumption, and which will grow something like 150,000 metric ton or so by the 2037 and 38. And the trend continues. This will further, if we see in the mid of the century, it will reach quite high. And but actually this, again, if all these ICAP recommendations are taken into account, then we can reduce this refrigerant consumption by 25 to 30% by the year, but we envisage in 37, 38 and beyond. This shows the primary energy needs for cooling alone. We are talking only for the cooling. And if we see in the current level, 2022-23, again, it's about 100 million tons of oil equivalent, the consumption of primary energy for cooling, and which will grow something like 260 to 70 million tons of equivalent in the year, which are considered in the ICAP. This slide actually, it calls for some integrated approach for reducing cooling demand and use of refrigerant and energy. If we see all whatever slides I have shown so far, talked about, and all of us this recognize that some, it's not an individual, element which we implement and we'll get some energy. Of course, this gives always, like we are trying to use the improve the energy efficiency of room air conditioners. That's very important. But at the same time, there are some other elements which can also be. So, but I feel always that an integrated approach should be applied in the building designs, which will lead to reduction in the cooling demand. Of course, once the cooling demands goes down, then of course refrigerant use and energy use will come down. If we see the elements, what is that? First comes the building design. That's the envelope, how to improve the design of this. And this I will be talking a little more on this aspect as the today's topic. And of course, the efficient building systems. Then next comes whatever cooling is required, then we should use the energy efficient HVAC systems. Then of course, operation of the building operations and controls should be taken in due consideration, and even the maintaining the indoor temperatures of the order of 25 plus minus 1 degree Celsius. That's also important. That will lead us, in the energy efficiency in cooling for buildings. Just actually in case of the building envelope design, if we see what quick wins or quickly we can see what elements are there. One is the building orientation, which always we recognize that building orientation contributes in the reduction in the cooling. The window to wall ratio, which has been well recognized. External shading, hollow masonry bricks, cavity walls, light colored reflecting coatings on the roofs and the facades, the insulation in the roofs, vegetation, natural ventilation, and building again to give slightly bit of the movement to the air or velocity in the circulation in the building space. Even we are using the active cooling systems to enhance slightly the the circulation, the ceiling fan or some sort of circulators may be important, which can give a feeling of reduction in temperature around the occupants. This shows that, of course, all of us know, because the connected distinguished delegates are mainly from the construction industry, and so they are knowing, but just I'm put these slides together and may remind us what is happening and what is to be done. So we see that there's a building orientation may contribute substantially, in reduction of the cooling load, if actually the windows are placed in the north and south facades, basically in that. So that can reduce, and of course the minimum windows should be, in the east and west facade, that is. And of course the window wall ratio plays a very vital role, and it can be as low as WWR 20%, and some buildings are seen even actually about 95, 100%. That is of the order. But if we see in our climate conditions, a window wall ratio may be something of the optimal value, maybe 20 to 40%. That can serve the purpose, that can give the daylighting, as well as some light or heating rays during the winter hours, if it is properly oriented. The external shading is very important in again reducing is one of the important aspect of the passive cooling, and it is seen, but some of the buildings are coming up which are which have not taken into account such measures, but I think it should be applied, because not only the aesthetics of the building is important, but at the same time, what we are talking about, the reduction in the cooling demand and refrigerants and energy should also play a vital role. So in case of the north-south facing windows, of course, the horizontal external shadings may serve the purpose, while in the east-west, we normally have the straight vertical fins, or maybe a slant vertical fins, depending on how it is facing, and some aggregates also can be used. Mutual buildings, these shadings can also be utilized. That can also result in the reduction in the heat loads. Of course, the vegetation, plantation of trees, and that can also provide. I have just put one photo of this Indian Institute of Technology, Delhi, from where I come from. And this building was constructed way back in 1964. And this building is in the east-west facing at that point of time, due to the whatever reasons it was taken. And in this, we see all windows which are facing the east-west side, they have the vertical, external shading, and which serves or which actually most of this area at that time and even now is not totally air conditioned, and still it maybe ceiling fans, and some portions, some laboratories may be air conditioned, some office rooms may be air conditioned, but the whole, this is not a centralized air conditioned building. So you can see, so long actually we have lived comfortably with that without, but actually there are other passive methods also being used in this building, which gives the comfort conditions to this building. The use of hollow masonry blocks and cavity walls can reduce helps in reducing the cooling load because the air gaps, as all of us know, air is a poor conductor of conducting heat, and once these are used, they are equally strength. They have, I mean, these are well known in the industry, and the strength of these walls, bricks, or masonry blocks, they have been tested well, and they can be utilized. Maybe little expensive initially, but similarly, the cavity walls can also be applied. The insulation can also play a vital role in reducing the cooling load, and there are variety of ways we can apply the insulation depending on the construction, the building type, and the roof. Of course, again, mixing with the PU foam with the concrete can also, roof insulation can also play an important role, especially in the top floors and maybe a little bit of, subsequent floors. The cool roof, which has been talked about a lot, and actually just I was seeing that if we have just in the right side, if you see uncoated roof, there's no, paint or tiles, reflecting tiles are applied. We can see almost 80% of the radiations are absorbed by the surface, and very small percentage is reflected from the surface. At the same time, if we have the reflecting coatings or tiles, here we can see a reverse trend. About 10 to 15% is absorbed, and while the major portion is reflected back. And that gives us, a very good idea. We can have, like, if outdoor temperature is 34 degrees, the ambient temperature, in an ambient temperature of 34 degrees Celsius, the indoors can be have something by 27, 28 degrees Celsius, which is quite comfortable just with a ceiling fan, because the comfort even up to 29 degrees Celsius, there's no need of any air conditioning. And this can be achieved by various ways: paints, tiles, different type of tiles, earthen pots, rivers. The lighting can also play a vital role. That means, again, have the proper day lighting and reduce the lighting power density. Of course, now this is a little old. The LED lights are very common now, or widely used, but there may be some older buildings where actually still some, we may go for the replacement by the LEDs. Ventilation, of course, in the buildings which are not centrally air conditioned, the proper ventilation provision should be provided, which can give the relief to the people. And as I said in the beginning, is not only to reduce the heat load, but that will reduce the heat load, take away the heat, whatever interior heat is there, or whatever heat is generated within the space, that will be taken away by this. And the comfort or discomfort days can also, or hours can also be reduced by this. Coming to the ECVC, where as Dr. Kumar just mentioned, I was one of the section chair, and got that opportunity, and going through that period, actually it's a very we say the ECVC 2017 where this was updated, but basically the ECVC came in 2007, and after 10 years some updating was there. But during the updating, we started with a very reasonable update, but it got in a very different direction. And currently the ECVC available, and if it is implemented as ICAP, envisage all in the recommendations for the building space cooling, we look for the implementation of the ECVC. And basically the ECVC, this 17, applies to the commercial buildings which have the connecting load of 100 kilowatt or so. And it introduces the passive design features like orientation, shading, insulation, daylights. It recommends use of energy efficient HVAC equipment, introduces the provisions of installing renewable energy systems, especially the photovoltaic systems, and even some storages, cooling storage, and sets the minimum energy standard. Basically, it works. Somehow the building should achieve the specified EPI, energy performance index. And there are 3 versions in that. One is, of course, the ECVC 2017, which looks for, if the building is compliant to this, we may find that to achieve the 20% efficient in the from the conventional building. And similarly, if we go to the ECVC plus, then it is, we can look for 30 to 35% energy efficiency in this. And there is a provision of super ECVC, and which can have as high as 40 to 45% efficient building over the conventional buildings. Of course, this ECVC is a dynamic document. It will go on revised and incorporate whatever features come, and and further improving about the EPIs. I actually also looking that though we are talking, the many measures, especially the passive cooling measures, have been applied by, and but still it has not gone to a level where, again, from the study it is clear that most of the people are not aware about these measures, but something is happening. Now, this is a building, or you can say the residential building complex, and developed under the affordable rate, affordable housing scheme of the PMY, and in Rajkot, and it's a 1 BHK residential building complex, and walls are made with 230 mm autoclaved aerated concrete blocks, and so this is what has been done. The roofs are having reflecting surfaces with the glazed tiles. Windows are partially opaque and providing sufficient daylights. Windows to wall ratio is low in this case, and but it has those buildings, about 90% of the windows can be opened for ventilation. So that's where this though is a very low cost housing, and where it has been claimed that 5 degrees Celsius, there's a reduced temperature in the space by 5 degrees Celsius compared to the conventional buildings. So that's what is a very, and this is what I was talking, there is a drop, discomfort per year. If you see the, in terms of hours, is expected to reduce from 6,200 to 2,500. So even actually in a further, some of the people like to have some cooling device, maybe the desert cooler or some active cooling systems, which will again be operating for a much lesser number of hours and use the energy. This is another building. Of course, there are several buildings in this. I am not taken, but just I took this example or to this case study. It was built up in way back in 2007. So that's how actually I prefer to use this example. And again, if we see this building is constructed with a lot of passive cooling interventions. There's an insulated AAC block, again, what we talked about, and which has a U value of as low as 0.04 BTUs per hour. And the roofs are insulated, and which is having a good insulation, and U values of the order of 0.03 BTUs per hour per feet. Again, the building, what we were talking about, the window wall ratio, again, the glazing is very optimized, and about 33.8%, which is within BEL, what we talked about, the 20 to 40% optimal value for our conditions has been double glazed units in windows, and daylight, about 87% of the space is having a provision of the daylight. And of course, it also have a provision of the artificial lighting. The lighting density has been decreased by 40%, as as per ASHRAE, over ASHRAE 90.1 2004, which is actually widely used code for the lighting, but this has resulted because of the drop in there's an increase in the daylighting hours and daylights, then it's a reduction. So there's a what has been claimed is there's a reduction in 60% or saving in 60% of energy in this building over the conventional building. It has also, as it has been envisaged in the ECBC, it has, it's what has been said, of course, it can be confirmed, but maybe one of the first net positive energy building in India, and it achieved 100% on-site energy generation through a 57 kilowatt photovoltaic system, and which is spread over 440 square meter or so. Then the third example which I have taken actually is again a building, a laboratory. So it's not a variety housing, the commercial building, as well as some institutions which can be taken here. And it's around 500 square meter lab, and which has insulated walls and roofs, high performance double glazing windows, adequate external shading, and lighting, which is limited 4.7 watts per square meter. But of course, there's a provision of task lighting, which as per the need. Is a net zero energy building, and lab has, it's again having a solar panel or photovoltaic panel, which actually, as said, 15% surplus energy is generated, and which is fed to the electricity grid. So, and the EPI is of very low, that is the order of 58 or 60 kilowatt hour per meter square per year. Just more or less final slide from my side today. actually, if we see from this graph, which is important for us, the conceptualization of the building and the design should be have a considerable time, and it may cost a little more than the conventional buildings, because it's little more we to go whether is a housing complex or is a commercial building, and may also lead to slight increase in the construction cost. But payback, if we see throughout the operation of the building, a significant or substantial reduction in the energy saving or payback, the lifetime, the cost can be paid back, in this. So from this point of view, it's a actually win-win situation. The current, as well as it's not that only the environmental issues have been addressed, but the cost of operation of the building or lifetime cost of the building is substantially reduced. Just I was saying, what are the options? The slogan is avoid, shift, improve. Avoid means use the reduce the high cooling demand. How do we reduce it? By use of the passive cooling methods or better design of the buildings in general. Then whatever remaining cooling should be made with the renewals, like you have seen a number of buildings, number of places, the photovoltaic units. And if it's more, you can have thermal storage. You can go in place of the room air conditioners, some sort of like district cooling, and which has actually what difference comes. One is actually you can have all is the, in case of the district cooling, all is the water cooled systems, which again more energy efficient or saves 25% energy in comparison to air cooled. Of course, depending on the area where we are, which climate. So, but definitely this. And then, of course, if you use the, if you can, last point comes the improved, that is the active cooling. Then in that case, we should use the energy efficient HVAC systems using non-ODS, low GWP refrigerants. So if we follow these just 3 steps, I think the lot of saving or reduction in cooling can be achieved and corresponding energy efficiency. And the lastly, this is actually I always say that if you see maintain the indoor temperatures, what has been talked about, the design temperatures. Normally, the buildings are designed at 25 ±1 as per the ASHRAE also, and many studies, even ISHRAE has also come up. And with that, you can achieve, rather than many times we see that maybe designed for 25 ±1, there's always a oversizing of the air conditioning units, and which can be run by something like 20 degrees Celsius or 22 degrees Celsius, but actually 25, 24, if you take, is a substantial. Thank you very much giving me this opportunity to talk about the passive cooling methods. Thanks a lot.
Thank you, sir. It's always a pleasure to listen to you, and we get to know so new things that from you that can be implemented in buildings. We look forward to having more net zero buildings in our country. Thank you, sir. Thanks, Eva. So now I'd like to introduce my next speaker. We are very fortunate, though our speakers are very busy and all were not able to attend the live program. We were asked to record presentations and be with us. Most of the speakers are with us today, and we will have our interaction sessions in the evening once we have the time constraint is over. So now our next speaker is Shri Vikram Murthy ji. Mr. Vikram Murthy is the Director, UNIVAC Environment Systems Private Limited, Mumbai. In the Indoor Environment Engineering, he is the Trustee of Tropical Air Conditioning and Refrigeration Institute, Mumbai. He has been representing AHRI, Air Conditioning and Heat Reservation Institute in India. So the ideas are further taken forward by Shri Vikram Murthy, and I would like to invite Mr. Vikram Murthy for his presentation. Can we have a presentation? Thank you, sir.
उससे वो तो चार्जिंग के लिए एक हाथ से
क्या चीज दबा गया?
आप कुछ करना नहीं है, आप क्यों कर दिए? इसमें जो बोलता है वो करता है।
जाते वक्त कई बार उनको देखा
Everybody, my name is Vikram Murthy. I am here to present on thermal control in public buildings. Public buildings are usually large spaces. They are constructed for the visiting and for the comfort and for the enjoyment, for the safety of such public buildings. And they must be not only comfortable, but they must also have very low energy consumption so that they have a low impact on the surroundings and have very small footprint of carbon emission. So let us see some examples of public buildings all over the world and of course indeed in India. So here is the first slide. This is a slide of a church somewhere in Europe. It is in the Netherlands, but it has been repurposed. That means it has been put to a different use now as a library. As you can see, I am putting on my pointer. It is a library. You can see all the books. They are going up to higher and higher levels. But the light is coming in only from the top. Very less light is coming from down. So therefore, the solar intake into this place is very low, and therefore its heat load is also small. It is beautifully lit. It is well used. It is very comfortable. Because of the high ceiling, all the hot air rises and it can be removed from there back for air circulation. Cooling or heating can both be done with very low loads depending on the number of people. If there are less people, the cooling load is less and it will be adjusted. This is a picture of a large museum. It is in China. Many of the old forts in India and many older buildings were made with very thick walls and small openings for light to come inside. There can be a courtyard inside. So for a very short time during say 11 to 1 o'clock in the daytime, light will come in but because there's a courtyard construction inside, the sun heat will never affect the people who are inside. So this museum offers great amount of comfort, just the right amount of light, very thick walls, so the solar gain never goes inside and it will never be hot inside. Or conversely, when it is cold, it will never be cold inside. It can be cooled or heated, a very small amount of energy. Here is a picture of an existing building, which is a Museum of Arts in in Brazil, Rio de Janeiro, Brazil. Later on, an architect created this wonderful shading roof. It is made of foam concrete. The architect is Zara Hasid. She is also the architect of new airport coming up in Navi Mumbai. And the use of concrete in any form you can imagine was her speciality. She passed a couple of years ago. But because of this wonderful shade, all this shading which is to be done at the correct time, the sun is going from this side to that side, is completely eliminated. So no solar gain, but enough light when the sun is just up in the morning or just down after 4 in the evening. So solar shading created by an addition done at a later date. This is a picture of our own airport in Mumbai. It is called T2, Chhatrapati Shivaji Maharaj International Airport. It was designed by architects from Chicago, Skidmore, Owings and Merrill. But this view of this airport, which you see here, shows you how much natural light that it admits very easily. Very, very high resistance to solar gain glass has been used. Very high, wonderful ceilings. And the air conditioning is done from very low level, just till about 8 or 9 feet, as is done in many airports in India today. So we don't have to cool the whole space. We only cool the level as tall as a man or slightly higher than man height. So the heat load comes down very substantially. And the load is varied based on the number of people by sensing with carbon dioxide meters. Lower cooling when less people, higher cooling when more people. Most of the cooling is at night when the heat load is very low. This is a picture of a botanic garden and visitor center in Brooklyn, New York. You can see how they've made use of the garden to come over the roof to create a cool roof. Very comfortable space, and the museum is all inside over here, surrounded by beautiful forest. So you can see a lot of carbon dioxide capture is taking place. And this museum is a public space, looking very beautiful, having very low heat load, low ceiling, no sun going inside, and a lot of corridors also are there. So finally inside it is quite naturally comfortable in summer and in winter. This is a picture of a library in Seattle, in the state of Washington, in Northwest America, United States. It has so much of glass. But because the architect, who is from Netherlands, he's quite a famous architect, I forgot his name. Yes, over here, Koolhaas. His name is Rem Koolhaas. He designed this building with glass to be oriented in such a way that at the peak sun time, it is in the shade portion. This is also offering shade, you can see. This is also offering shade. So the library is very large. It's always full of people. People are coming and doing their work and studying, and students and all. It's a free library. In fact, all public libraries in the United States are free. We also in India had a history of public libraries, but because everything is available on the internet now, less people go to libraries. However, this public building is used for many purposes, not only for reading books. This is a more recently constructed building, the Museum of African American History in Washington, D.C. Now, this building has an outer skin or an outer exterior layer of many layers or pieces of metal. They are either made of brass or some zinc or some combination metal. So they reflect light and sun very easily, and they allow only diffracted or broken rays of light to enter the corridor area. And so they create a very nice lighting pattern, but it is never hot or cold without mechanical cooling or heating inside the building, because it has such a large thermal mass. So it absorbs heat very slowly in the winter, and it rejects heat in the summer based on its architectural construction. This is an example in New York of how they use the space below the railway line which is going above, or the flyover. We are doing this in Mumbai also. All the flyovers below, the government is making very beautiful places for people to walk around. And because it's nice and shaded, it never gets very hot. It's made beautiful. It is kept clean. So here's an example of a public space which requires no mechanical ventilation, heating, cooling, nothing. But it is throughout the year a friendly place to come. You dress appropriately. You come in the dress of the season and you enjoy yourself over here. Sort of outdoors, but somewhat indoors, because it is somewhat covered by the existing utility of the railway line. So the temperature today, earlier in the day today in Mumbai, was 32 degrees centigrade dry bulb, 28 degrees centigrade wet bulb. That works out to 75% relative humidity and 27 degrees dew point. On a psychrometric chart, this is where it appears. Not very hot, but very humid. If we do cooling, we have to just take care mostly of humidity, right? And we need not worry so much about temperature because our body temperature is 37. Temperatures up to 28, 30 degrees are very comfortable for us. So a very small amount of cooling, but removing the humidity by dew point control will take care of any comfort application in Mumbai today. So the body is comfortable with a wide range of environmental conditions. Our body is very adaptable. Our own body temperature is 37 degrees centigrade. What makes us comfortable or uncomfortable? It is the air temperature, the radiant temperature of surrounding surfaces. If you stand close to a wall which is very hot because it's a thin wall, or close to a glass which is allowed huge amount of sun rays to come in, you will feel the heat, right? If there is a lot of humidity or low humidity, you will feel either very humid or very dry. The air motion, you put on a fan, you will feel more comfortable. Recommended by the Indian Society of Heating, Refrigerating, Air Conditioning Engineers in 2020, and it was approved by CPWD and the National Building Code very widely, and also put into their code, that temperatures should be designed for indoors between 24 and 30 degrees centigrade in India, depending on whether it is very low humidity or high humidity. If it's a high humidity place like in Mumbai, you can design for slightly lower temperature. If it's a low humidity place like in Jaipur, you can design for much higher indoor. This way, we are able to lower the cooling load in public buildings and in any building very substantially by adapting to the new norms of comfort and not keep it at 21, 22 degrees and very low humidity. Let us look at some old and historical perspectives in India. India is a very ancient country, and from hundreds and hundreds of years ago, the people have been comfortable because of natural processes. The Deeg palaces in Bharatpur in Rajasthan, it has hot and dry summers, 43 degrees centigrade in the summer, but the wet bulb temperature is very low, 22.5. That is the temperature of water or the surrounding mist or moisture in the air. It's a big advantage for us. So there is a water body at a higher level. Water flows from there by gravity, and through these fountains, it is not in use now, but through these fountains, the water spray would come and cool the surrounding areas by evaporation. Cooling by evaporation kept this whole large palace very comfortable all through the summer months. And of course, all of you know about the majestic Taj Mahal in Agra. It has hot and dry summers and cool winters when the when the dry bulb and the wet bulb also become very low. And because it's by the banks of the Yamuna, this water flowing gently by the side of the Taj Mahal, which is sitting on a very big stone base, very large. That is the thermal mass which you don't see above, but it goes right down deep into the ground. And that throughout the summer months, it is getting cooled. And in the winter months, it's getting even more cooled. So during the next summer, that thermal mass has got such a large amount of cooling done that it keeps the floor of the Taj Mahal very cool. And by radiation, the people feel very comfortable around it. There are many other ways of cooling by Jali method and so on and so forth. But over here, we are speaking of the radiant sink to absorb the surrounding heat in summer, acting as a cool radiant sink. and the thermal mass is like a large thermal storage. We are applying this thermal storage methods in modern buildings today by storing large amount of water in big tanks under the building, which are kept cool by refrigeration at night and used the next morning for circulation, right? And this is an institution. It is IIT Kanpur. I studied here many years ago, but even long back in 1967, there was a 1,000-ton district cooling system which cooled the laboratories, the library, and the lecture halls and the classrooms. And it was because of diversity that they could switch the load to lecture halls, to classrooms and laboratories, to the library. The library had a very nice spray pond instead of a cooling tower. So even that many years ago, 50 years ago, there was, or even longer, there was a concept of this district cooling system existing in India, which was also done in the Baba Atomic Research Center, 3,000 or 5,000 tons of air conditioning running all over the buildings, which allows large buildings and multiple buildings cooling with very low load because of the diversity of the load. Okay, so this is another building which you can see. This is a very wonderful, nice, good building. It is the General Post Office in Mumbai. It's in the heart of Mumbai, built many years ago. But because of its high ceiling, lighting coming from above, large natural draft air passing through, it is always comfortable even in the hot period, in the humid period. And people come and go, and the people who work here stay the whole day. There are fans all over the place. So it is naturally ventilated, naturally cooled, and no need of mechanical refrigerated air conditioning. Close by is the Victoria Terminus, Chhatrapati Shivaji Maharaj Terminus, Central Railway. It also has this beautifully interior, high ceiling, created in Gothic style columns and roofs and so on and so forth. Again, ventilation brings in air naturally. It goes out from the platforms. There are fans, large fans everywhere. And it is quite a comfortable place despite thousands and thousands of people are coming in and going out all the time. All right. So we must build to take advantage of local climate. That is what our ancient and our older architects did, and they are starting to do again. We must use design strategies that use high thermal mass. I showed you the Taj Mahal. Natural and installed insulation. Either you install insulation or it can be a very thick wall. Use the correct construction materials. Use windows on shaded facades where the shading is there. Use of awning, that means chhajja. Use many chhajjas, shading by trees, surrounding trees. Cool roof, keep the roof very cool. High emissivity reflecting surfaces, that means the paint and the outer surface, it must just reflect the heat and sun away. It is used a lot in Jodhpur by natural available material. Natural wind ventilation, evaporating water bodies, fountains, all these things can be there. And indeed, they are there in Delhi. They're there at the Baha'i temple, which is there, more recently constructed. It's not a very old construction, though by now it is, I suppose, a few decades old. But it's a beautiful place to go to feel comfort by natural process. Any time of the year you can go there. It is naturally lit. Of course, there is artificial lighting, but it's a very comfortable place to go. There's auditorium inside. It is like a place for doing prayer, whatever religion, whatever faith you have, or even just to go there as a visit to enjoy natural method of keeping a public building comfortable. Here is another building in Delhi. It is the India Habitat Center, designed by an Japanese-American architect who settled down in India, Joseph Allen Stein. He did many lovely, beautiful buildings all over India. This is one of them, India Habitat Center. You can see it has got recessed windows everywhere. Not much sun ever comes in. It has very thick brick walls, so that also keeps the solar gain out. And it is well constructed with these sun breakers, shading in the right places. So except if you stand right out in the open for long in the hot Delhi summer, you will feel uncomfortable. But the moment you will walk into the building, you will feel automatically quite comfortable, even before you feel the effect of air conditioning, which is inside and which is minimal. And now it is fitted with more carefully controlled operations so that it saves energy and keeps a lot of good companies, institutions, programs, and many functions go on over here. And It's a very friendly place for people to visit. India has many climate zones. This is the hot and dry portion. This is the opposite. That means it is hot in the summer, cool in the winter. This is the coastal area of India. It's a very large, 7,000 kilometers of coast. So these coastal areas enjoy not very hot conditions because they are cooled by the sea. So they are very comfortable. They also have plenty of rain because the Western Ghats and Eastern Ghats have huge amount of rainfall, much more in the Western Ghats, and they are perpetually in a very water-rich condition. So we can make advantage and use of all of these. Despite that, India is the third largest producer of energy, close to 1,500 terawatts of energy, although we have the seventh largest land mass, and we have a very large population, no doubt about that. But we need energy for our people, for our industries, and we must be conscious to try and use it in a very, shall we say, in a well-planned way, and in a way that doesn't overcool or overheat when it's not required. Okay, so this is something to tell you. So we generated in 2021-22, I told you, 1,559 terawatts of electricity, out of which cooling energy demanded close to 10% of that in 2018-19. So actually in 2020-21, it must have been more. But it is projected to become 5 to 6 times that by 2038. And of course, our generation electricity also will go up. Our attempt should be to keep this very low, right? So the terawatts is a very large number. 1 kilowatt, we understand what is 1 kilowatt, 1,000 watts. Usually in a home, 3, 4, 5 kilowatts or 1 or 2 kilowatts is more than enough. And a megawatt is 1,000 times that. A gigawatt is 1 million times that. A terawatt is 1 billion times that. 1 followed by 12 zeros. Energy we are using. So many kilowatts multiplied by hours of cooling. This is what we have to carefully bring down as a conscious nation. All of us here who are listening, who are architects, engineers, practitioners, contractors, specifiers, government people, all must try to help to save energy and use nature, natural processes, which India has enough of diversity of climate to try and use natural processes. So the India Cooling Action Plan released by the Ministry of Environment, Forest and Climate Change in 2018 released 2019 the indirect direct evaporative cooling system as one of the alternate ways to cool large spaces, and it is just using evaporating water in single or two stage. Structure cooling, which is being applied now to some of the new public buildings coming up in Delhi, where you circulate water in pipes in the building and on the roof and allow night sky radiation to take away the heat. Radiant cooling. So we will see a little bit about all of these. And of course, we must never forget that most of Indians, over 60%, stay cool with a fan. Even the people who have air conditioning, much of the time, they can be comfortable with a fan. But we must make fans with very low motor consumption. Brushless DC motors will save or reduce energy consumption by as much as 65%. And the Bureau of Energy Efficiency is moving forward to see in some years' time, only brushless DC motor fans will be sold, and the energy will come down so much that it will be good to have cooling by fans as much as possible and cooling by evaporation. Evaporative cooling for India, which has composite climate. Wherever it is hot and dry, we must use evaporative coolers. We see them in Delhi every summer. They are made in the cottage industry sector, but they must be made with good engineering, brushless DC fans, very low energy pumps, filters to keep the dust and the other pollutants out. And so we can have two-stage cooling. First, we cool the air without coming in contact with water, bring down this temperature, and then pass it through evaporative cooling. And we can get very low temperatures, as low as 1 or 2 degrees below the wet bulb. So how nice it is, but you have to exhaust the air because it is very humid. Now, let us look at some innovations which are prevalent and which are being practiced for commercial buildings, comfort buildings, public buildings in India and elsewhere. So radiant cooling, I see a lot of this application by large public corporations, including Infosys, who have done a huge big campus cooling by radiant cooling in Hyderabad. Also, they have a similar building, looking the same, identical constructed building with conventional chill water, air circulation. And they have found that the building with radiant cooling, with the radiant pipes either in the ceiling or in the roof, on the false ceiling or on the floor, they are allowing people to lose their body heat because that is a cooler surface. And as much as 30% of the energy is saved. Radiation is a wonderful thing. It is proportional to the fourth power of the temperature difference between the radiant temperature, the mean radiant temperature produced by this, and your body temperature. So and also it's proportional to the area. So if the area of the floor is the largest area compared to any wall, and it is free. Usually the floor, nothing is there. So you can bury the pipes in the floor, very quick and easy to do it. There is one nice mall also. Mall means shopping center in Hyderabad, which has done cooling by radiant cooling. If they had done it by conventional methods, the cooling load would have been 35% higher. So successfully done. You can improve air circulation with some fans. You can have some ducting blowing colder air to remove the humidity. Many innovations can be there. So radiant cooling is certainly going to increase a lot in public and commercial buildings in India. And it is the future of low energy cooling. And we get used to comfort by losing body heat to a cooler surface instead of trying to feel some cold air blowing on us, which we are used to now. So we have to adapt to the changes. Another example of a large gym, sports center somewhere in India or wherever it is. So this whole floor, the whole ceiling has got the radiant pipes, and it is this lady losing body heat very rapidly to that space and feeling comfortable. The best part is no noise. There is no air blowing anywhere unless you have some little amount of air for circulation. And you can see the radiant panels are being made and they are joined together with pipes and connected. So the convention comes down because air is cooler, it comes down. And by radiation, the heat goes directly away and you have a very happy customer and not even very cool. Only a 65 degrees Fahrenheit, this is about 12, 13, 14 degrees centigrade coolness is over there. And so everyone is very happy. And the mean radiant temperature is 23. You can make it even higher and you can have a separate system for low temperature removing humidity. Okay. Recently in Singapore, some inventions have been practiced, have been applied where they are using special adaptive glass, using layers of vanadium dioxide, nanoparticle composites, very low emissivity. Low emissivity means it doesn't give up its heat, or on the reverse way, it can have a high emissivity when it is hot outside. It has the electrical components. It works by exploiting the spectrums of light responsible for heating and cooling. The infrared portion of the light, which is the hot portion, that is disturbed by this glass. And so it keeps the coolness in, it keeps the radiation out. And in the winter, the reverse takes place. Of course, in Singapore has no winter. So this glass is applied to many of the existing buildings. And it has produced wonderful results of reducing both solar gain in the form of visible light, as well as solar gain in the form of solar radiation heat, which is transmitted through glass. So this is displacement ventilation. I told you in Delhi, Mumbai, and many other airports, we are cooling only up to man height. We are not cooling from above. We are cooling from low level boxes. You will see in the airport, there are some big boxes with some opening diffusers sitting round, one sitting on it. And they are blowing air and taking away the heat only at the lower level instead of doing it from the top. And by doing it from the top, we gather all dust also, and that settles on the floor. So displacement ventilation in large spaces is far more economical to do and practical also, as well as it is much cleaner to do by displacement ventilation. This is another practice, wraparound coils. So we are exploiting the available heat energy available in the heat which comes in for preheating the air just to dry it up and then wrapping it around so that we are exchanging the heat and cold. Now cold air comes here, so it cools this coil, the pipes which are buried in that coil. These are extra coils. So the coolness of here is transmitted to the pipes to here. So pre-cooling takes place, and over here, because it is again cool, drying takes place. So I'm sorry, here because it gets a little warm, the drying takes place. So we are having the heat pipe system for pre-cooling and after cooling, taking out the moisture. And this also allows us to take large amount of fresh air from outside without worrying about its high temperature or high humidity. So these wraparound coil and hybrid cooling systems became very popular and practiced during COVID time, when it was advised to take more than 40% of air from outside and filter it well and not recirculate it. Okay. Underfloor air conditioning is like displacement. You blow air from down, you have a raised floor, and you can move the diffusers around here and there, because the whole underfloor is a plenum for air to move around. And so the people can adjust amount of air which they want to feel comfortable. And again, the cooling is only restricted to the height of the people and not the full height of the room. So this underfloor air conditioning is also, I think, it is going to increase its occurrence in commercial buildings and public buildings. The first cost is a little higher for creating the false floor, but you see, it is so nice for maintenance. You have to just open up the modular tiles and attend to any damper or grill inside. You can open up many tiles and clean the whole place. You can move these partitions around and create a new office layout. So it is quite nice to do it. And you have the whole taller ceiling, although you're taking up some space at the bottom, 12 to 14 inches, maybe about 300, 350, and less than 400 mm, 350 mm. But on the top of this, we don't have to have any false ceiling for air conditioning ducts, and the lights can come directly on the slab. And also nowadays, lighting is all task lighting. The lighting is only at the level where the people want it, and only some diffuse lighting is there. Plus, you can see a lot of glass is there in this particular picture. So this glass is modern, very low U value or very high resistance to heat coming inside. All modern airports are using this. It is up to 4 times more efficient than the glass, which is conventional glass. So you invest higher cost in glass, and a lot of research is there done by the glass companies of India to give excellent glass. And India produces a very high volume of glass, which is exporting also, and using in the place where there is a shade on the outside. The north side is always in the shade. The northeast is also a good side to put. West and east, we must put less glass. And in the north and northeast, we can put more glass and bring lots of light in, but heat will not come. Right? Then there is something called chilled beams. They are similar to cooling units. They have a coil within them. So they're like a large looking diffuser, which has an air pipe inside, and air is blown. And by induction process, air, because air is blowing here at higher velocity, so air is sucked inside because hot air rises, and because there's a air stream inside, it induces the air to come in, and the air goes past the cooling coil, rather it goes in from the sides and comes out from the cooling coil very gently, and in a very quiet way, it cools very large spaces. So the chill beams have been applied, and we have a separate dedicated outdoor air system, DOAS. Because these chill beams cannot take care of humidity, their temperatures are ranging in 17, 18 degrees centigrade, and the lower temperature divided path of putting the air separately is admitted by the dedicated outdoor air system, the cooler air for removing the humidity. So this is a nice way of doing. Divide and cool, not divide and rule, but divide and cool. Divide the air conditioning load to sensible cooling by chill beams, and humidity removal or moisture removal by separate duct system. Divide and cool. Here is a nice, I wouldn't say nice, but a nice, a good invention or a good application of something called an adsorption chiller. It's not absorption, not AB, but AD. It is using the principle of desiccants, which absorb moisture very quickly because of their nature, and also using low pressure so that the water boils at very low temperature. And by having different chambers, this passing from one chamber to another takes place inside. It has an evaporator, 2 adsorption chambers, and a condenser to reject the heat. Warm vapor condenses to a liquid without using any moving parts. So the warm vapor condenses and it changes state by virtue of the change in pressure which are applied and the desiccant which is able to pull out all the moisture. Silica gel lowers humidity inside the evaporator, which allows water refrigerant to evaporate at very low temperature, and we get chill water at 7 degrees. And the only energy we have to pump in is warm water at 36 degrees centigrade. So you see, we can get warm water 36 or 40 degrees very easily from waste heat, or we can produce hot water by solar thermal, which is very popular for heating water. So with solar thermal, we can have huge area dedicated for solar thermal, creating the hot water to power these adsorption chillers. They are available now up to 350, 400 tons. They are made in India. They are exported. They are made outside Delhi, a good company, and they are being applied slowly and steadily. First cost is high, but maintenance is low, and application is so good that energy almost free of energy. At night time, you will have to create thermal water storage to run it continuously throughout the day and night. So I think this is also a good innovation. Now let's talk about something in the end, towards the end of my presentation. It is about adaptive comfort. There is a standard also. It is standard 55 of ASHRAE. And in India also, we have indirectly included that in our energy conservation building code. That means humans have an inherent ability to adapt to climate. That has eroded with the comfort available from decades of mechanical cooling and heating. So, our being adaptable to the change in climate, we have forgotten and we have lost that ability to adapt because of 40, 50 years of comfort cooling and comfort heating in the winter or summer. And so we don't adapt. I grew up in North India and also in the South in Hyderabad. Both the places are quite hot in the summer. But we move there from time to time. You might move also during the summer to a cooler place, which is also not bad. It is not that only wealthy people move. Anyone can move. There are easy ways to travel, or go to a cooler place like a forest, a village, where there are lots of water bodies. But anyway, talking about the city, people lived in the city, they went to school, they went to office. There was no air conditioning. And in the winter, there was no heating. It is by our body clothes, by being adaptable and regulating how we face the environment change, that we are able to stay. We have to go back to that because sadly, we have overused the energy available in everywhere. And so we don't have enough energy more to do that. So we have to adapt. We must have appropriate clothing. We must set the cooling temperature to 24 to 30 based on humidity ranging from 40 to 70. Use circulating fans, and you can turn on the active mechanical air conditioning only when the outdoor temperature rises above 35 in dry climates or 33 degrees centigrade in humid climates. So you see, no need of putting on this heating and cooling till it is too hot or till it is too cold, right? In Mumbai, it is not required air conditioning most of the year, except for the humidity part. For that, you don't have to run the air conditioning at very low temperatures. You can, but you lower the amount of air passing over the cooling coil, then automatically dehumidification takes place. And by putting on a fan inside your place of work, you will feel quite comfortable. You can see this fellow working over here. This is just a drawing. But because it is a good condition outside, you open the window, allowing air to come in and putting on his fan for circulation. Of course, there is a problem with dust and this and that, and cities are creating PM particles of small size, 2.5 and even smaller size, and even PM10 and PM5 are harmful. So therefore, we may not open the windows unless we are able to draw fresh air into a building through filtration, which we can do. In the evening time, in the morning time, we don't have to run the air conditioning. Let the ventilation systems run with well good filtered air. Let the fans be running. Let people work with such an environment, because no longer do we have to think that we have to put on air conditioning at very low condition, because that will not be the case. Managers of buildings will ensure that they run the place with the amount of energy which they are allowed to expend every month. So this is my last slide. Thermal control in public buildings. Our collective lament. That means our collective, we should be sorry about this. All of us who are having the privilege of enjoying mechanical cooling or mechanical heating. You walk through a city on a stifling hot day in May, and you will find people, they are driving cycle rickshaw, they are pushing something, they are hauling goods on their head, they are constructing towers of glass and steel. We have removed all the trees, we have removed all the grass. Only a few people, just 10 to 15% or 20% of the Indians, they are protected in air conditioning homes or offices. Those who can afford are in good comfort. Those who cannot are becoming worse and worse and worse. These kind of people are becoming more in percentage, and the people living here, percentage is less, but they are drawing more and more energy. Wet bulb is rising. When wet bulb is rising, evaporation also doesn't produce enough cooling. The social cost is high. We must consider the social cost of our actions. Apart from global warming and everything else, we must have public buildings which people can go to when it's very hot. Delhi has done very nice by creating shelters, whether they have fans or what inside, I am not sure. But it is required that we keep public spaces and shelters comfortable for everybody by using our engineering ability. So this brings us to the end of my presentation of thermal control in public buildings. And I hope all of you will take time to think and act on some of my suggestions. And of course, each of you is capable of doing even more new and better things. India is a large country. We need more people to apply all such principles. So thank you very much.
I'd like to thank Mr. Vikram Murthy for interesting suggestions that we can do in our daily lives, and when especially the designing and construction professionals, they can give a deep thought on these things. And next time when you're designing a building, I think we should consider public spaces and everybody who is living in this country. Thank you. And for the next presentation, I would like to invite Shri Akash Deep. Shri Akash Deep is the Senior Program Manager from GRIHA Council. GRIHA stands for Green Rating for Integrated Habitat Assessment. So he will be speaking on Green Rating for Integrated Habitat Assessment. And I invite Shri Akash Deep. You're welcome.
Hello, ma'am, and hello, everyone. Thank you. And once again, it's always a pleasure to interact with the CIDC and the participants of this workshop. It's a series, and it's finally culminating at a conference, which is being organized today by CIDC. I'll be just sharing my screen. Just give me a second. Ma'am, please confirm if the full screen is visible.
Yes, it is.
Okay, thank you. Okay, so we have a very interesting presentation just before me on various sustainable design measures which can be implemented at the building level. Now, to brief about what we do and how GRIHA is involved in the whole green building requirements and green spaces. So GRIHA stands for, as ma'am said, it's Green Rating for Integrated Habitat Assessment. It's a green rating, national green building rating of our country, adopted by Ministry and Government of India. We work with various stakeholders, private buildings, government buildings. Now, when we talk about buildings, everybody is a stakeholder, whether it's a small young child, whether it's an old age person, whether it's lawyer, whether it's everyone. So the building infrastructure involves everybody as a stakeholder. We all use buildings. We all, whether we work in it, whether we stay in it, whether we go to office in it, whether we go to a restaurant. So building structures, building infrastructure around the country is a very important part in reforming our lifestyles, basically. One, making us comfortable in it. And second, we make sure that we are using these infrastructure optimally, neither overburdening it, which means resource efficiency is taken care when we are using these buildings. And that's what we evaluate in RIHA rating, basically, actually. So starting with the very basic question, why do we need buildings? And we all know that we have made buildings for our comfort, to protect us from climate. Now, but when we talk about our comfort, it's totally undefined comfort. Everybody has a different comfort gambit. But if the building is not giving the users, us, the basic comfort, there might be something lacking in the current design. And that's what the challenge in the current designs are. So the building gives you comfort from climate. What are these comforts which your building should give you? One is thermal comfort, obviously, not too much hot, not too much cold, not too much moisture. So everything you're building as a body, you should be comfortable sitting in that space. Similarly, it should give you visual comfort, not too much. If there is too much glare coming from the sun, from the window, if it is totally dark, you don't have light, the lux levels are very low. So visual comfort is very important again. Third is acoustical comfort. If the building is not blocking outside noise, if the building itself is generating too much of noise, you're not comfortable at the end of the day for using it. So each building has its own ambient noise level. So we should make sure that the buildings which we are designing are as per the current requirements. And finally, the modern day issues, which are indoor air quality. So the air which is coming inside, now it can be naturally ventilated building, it can be an air conditioned building, it can be a hybrid building. Whether your building design facilitates a good air quality inside the space. It can be through mechanical systems, it can be through natural systems, the vegetation, because when we talk about mechanical systems, it can only take the outside air, purify it a bit and give you inside. It cannot produce oxygen. Inside a space, oxygen can only produce, we all know, the plants are the only thing which can produce oxygen. So to make sure that the spaces inside are breathable, that's what the current design should help. And that's what we are looking for. Now, this is the world map, and which you have seen multiple times. What I want you to take your attention to is, if you see this, this is us. And this is the band which we are located to. Now, if you see in this band, the global band which we are, where we are, and if you try to find out any developed country in this band, other than some parts of probably Dubai and China and some parts of these areas, Malaysia, rest all, the developed country band is either above or below us. So you take North America, South Africa, Europe, Russia, Australia, even Japan. So all these, we are in the band which is basically near the equator. The countries in this band in general are either developed or underdeveloped. But what happens is, when we want to aspire, we always aspire, okay, US is the best developed country, let's all aspire to become US. We don't have that flexibility to have that comfort levels as US. We don't have that requirements. We are not in that climate zone. We don't have that building construction practices. Our requirements are different. And very easy example of this is our lifestyle. Now, when we talk about India as our own lifestyles were sustainable when we were local, when we were Indian. The moment we have become global, we have lost our sustainability in our lifestyle itself. Our food for each state had that basic sustainability in itself. For example, you had, if you go to Rajasthan, the food was having that much chili in it because chili helps you perspire. When you perspire, hot air automatically cools you. That was the food practices. Similarly, the Western, your coastal regions have lots of rice in it. So the food practices were sustainable as per each state. The clothing, which we used to wear in each climate which India had in different states, it was designed as per your climates of each state. So we were sustainable in the climate requirements. We had different wear in Rajasthan, we had a different wear in eastern states, which we have different wear in your southern states, coastal regions, ventilated region. Similarly, buildings. They had their own language in each state, in each climate. You see a building, you can tell, okay, it is from this part of our country. Modern building, you see, and nobody can tell which part of this country is that building located in. Basically, that's what the modern design has done. It has globalized to make us unsustainable, basically, somehow. So each building, the old Havelis, the old temples, they were designed as per the local climates. The sloped roof in the rainy areas, the flat roofs with the mud fuskas in the hot area. You have Rajasthan city, which you had compact planning so that the heat from the outside sun is reduced within the built environment. So the building design was actually governed by the climate. Nowadays, we are trying to make climate responsive design, but having base as a modern architecture defeat that basic purpose. But now we are developing, which means common clothing. Doesn't matter what you are. We all want to have office decorum is, corporate decorum is, a tie suit is what is required. The basic sustainable clothing has gone. Uniform clothes, uniform transport mode. Everybody in a car rushing towards the work, rushing towards their homes. That's what we have led into as development. Even the language is uniform. Everybody understands the marketing language. If you do not invest in marketing, nobody takes your product, whether it's a very good product. So, food, as I said, we had lots of different food as per climate, but now everybody wants pizza, wants burger, wants chow-mein. That's what our food habits have evolved to, let alone sustainable. We used to have food habits as per the requirements of the climate. Now comes the building. Nobody can tell from the slide which building is located where. That's the challenge. All cities, exactly same buildings. Whether it's New Delhi, whether it's Mumbai, whether it's Bangalore, West Bengal, Bangalore, anywhere. All cities have exactly same building. And we have different climates in all cities. Still, whichever city you take across India now, and now even the tier 3 cities and tier 2 cities which were away from the urban development are pushing that we want a modern building. And modern building for the language is glass building somehow. Uniform buildings. And we are not limited to buildings. We have even gone ahead and made cities which are copy pasted. So this is Delhi. And we play a game with school students. Can you spot a tree in this city? Can you spot a tree? That's how we have transformed our cities. No garden spaces, no green breathing spaces in our cities, just building landscape. That's all. I think so. This is Pitampura, Bangalore, Chennai, Delhi, West Bengal, all cities alike. So, what is the challenge? The challenge is this, which is used by the current generation a lot. Any problem, the solution is on Google and Wikipedia. Just go there, look for it, then do the most two favorite things, Control-C, Control-V, and the work is done. This process is what is killing us. This process cannot make anything sustainable. So this is neither sustainable nor cool. The intent is that each problem is a localized problem. You have to have a localized solution. You can look for information for that solution, for that problem, but solution has to come locally. It cannot be a global solution. It will not work for us. So here comes Greha. Greha is basically a tool to measure greenness of a building throughout the life cycle. That is from starting until the building journey is complete, which is 60 years to 80 years, depending on where you are building the building. The basic principle which Greha has been created is what gets measured gets managed. So if you want to measure anything, manage anything, whether it's time, whether it's resource, whether it's human resource, it has to be measured. Without measuring, you cannot manage it, because I don't know how much I'm consuming, I can't manage. So Greha gives you those benchmarking to perform better, measure to manage. Greha has been recognized by Ministry of New and Renewable Energy as the National Green Building Rating since 2007. It has got multiple recognitions, and the most recent one happens in 2015, in which, if you all know about the Paris Agreement. So Paris Agreement is that that was the first time that 192 countries from the globe came together and signed an agreement, agreed on something, that climate change is happening. We all agree that there is an increase in temperature globally. Carbon emissions have increased. Let's try to limit that increase in temperature by 2 degrees Celsius by 2030. Now, interestingly, we all are failing very badly after even signing this agreement. It has been now 7 to 8 years since this agreement is signed. But what is happening is in this commitment to reduce our carbon emissions, each of the country has committed to globe that we are reducing carbon emissions in various sectors. So in this document and all the things which are reported in the built environment to the global community by Government of India, the data is sent from GRIHA. So, for example, how much energy is saved, how much water is saved, how much carbon emission has been reduced, how many green buildings have been rated or built in India. So that data from India goes through GRIHA to the global community. How it helps India? Now, if you're doing something, but you are not getting a rating and your number is not being captured in the whole rating process, it is not going into the government reporting process, which means even if we are doing a lot of good stuff individually, as a country, we are not representing it to the globe that we are doing this good stuff. So that's how the rating becomes important for any of the projects or any things which we are doing. That's how the reporting happens. Every year, there's a biennial report which goes in which it says the numbers which GRIHA has achieved in the built environment for mitigating carbon reduction in the built environment. Now, in India, the buildings as a subject, it's a state subject. Since 2009, the central government has made mandatory that all central government buildings have to get a 3-star rating, which means all your airports, IAMs, your central Vista projects. So all the central government buildings are automatically GRIHA rated. But when it comes to state subjects, the buildings is a state subjects basically in our country. So what the states have done is they have tried to push various incentives in the market for private developers to adopt GRIHA or green building rating implementation. One of the incentives available in most of the states now is extra FAR, and which means if you build 1-star, so GRIHA can give you 1 to 5-star, 1-star being the minimum and 5-star being the highest. So if you can make a 5-star GRIHA rated building, for example, Haryana gives you an highest 15% extra FAR. Now, interestingly, when you talk about extra FAR, this extra FAR is given in the initial stages. Once you get a final rating, building is complete, you go back to the government and say that this is my rating, and accordingly your building gets an extra free FAR. Otherwise, there's a penalty if you are not meeting the required star rating. Most interesting incentive was there from Maharashtra region, Pune region. What they have done is they did a two-side approach. The developers were given premium rebate, while the users, us, the buyers, were given a property tax rebate. So because of this, what you will see is Maharashtra has the maximum adoption of GRIHA also. This incentive was launched since 2009. So Maharashtra has the maximum number of projects which are GRIHA rated yet. Further, there are other incentives such as fast-track environment clearance by Ministry of Environment, Forest and Climate Change. So if your building is above 20,000 square meters of built-up area, you can opt for a fast-track clearance basically. Now, in GRIHA, the building structures, the built environment has been divided into two basic sections. One is new building, and second one is your existing buildings, basically. Doesn't matter what you are creating. It can be a dhaba, it can be a school, it can be a restaurant, it can be an office, it can be a residence. The rating takes care of the typology. However, the rating structure, for example, the new buildings have been divided into 3 scales: small scale, medium scale, and large scale. What GRIHA believes is that when you're making a building, whether it's small, medium, or scale, your strategies to implement sustainability differs as per the scale. So if I have a small building, I have a limited option to play around. Doesn't matter it's a school, doesn't matter it's an office building, doesn't matter it's a residential building. The building design, there's a limitation to what I can do in the small scale building. But the basic calculations on typology is only in terms of typologies, so that the rating tool takes care of it. Now, the SWA-GRIHA rating, simple, versatile, affordable GRIHA, rates anything up below 2,500 square meters of built-up area. Now, this tool is very interesting. It is a design cum rating tool. So an architect can put in what he's making, where he's making, as which city he's making. Now, the tool suggests, okay, as per the city climate data, what is best for that design and how he can tweak his design to make a better building. So it's a design cum rating tool. The GRIHA is the major version, and the GRIHA version is applicable to anything above 2,500 square meters of built-up area. So this is almost all the building structures. Then you have GREHA LD. This is for large development, which is site area above 50 hectares. Now, this is for your IIMs, IITs, your housing societies, which is above 50 hectares. Now, these large sites takes around 15 to 20 years to develop. So this rating evaluates what will be the impact of your development after 20 years. Will you be sustainable? Have you taken that into your account? And all that thing is evaluated in LD. So now if you see anything under any scale which you are building can be rated under these three rating variants. However, there was a separate demand by Government of India that we have the PMAY requirement for Pradhan Mantri Awas Yojana. We require a specific evaluation tool for affordable housing. So any project which is going under PMAY, there's a specific rating which is created for them that is called the GREHA for affordable housing. Rest all projects goes under these three scales. And we have case studies which we'll discuss in the presentation of these ratings, what they have done, how they have achieved, and how simple design measures can actually make building clean. With regards to existing building, you have two major ratings. This GREHA for existing building takes care of almost all scales. And then you have GREHA for existing day schools. Now, this rating is very interesting. What it does is basically, it does not require GREHA for existing day schools. What it does is basically it asks the students and teachers to work together to collect data and understand sustainability at their school and take a rating for their school. So there's no third-party engineer, architect, third-party consultant hired for taking this rating. The intent of also making this rating so simple was that we all know that the 2070 target, which our Honorable PM has given us, 2070 net zero India, you and most of us will be gone and buried. Our new generation which is coming, if they are not taught well in advance, they will not be able to meet these 2070 targets. So they are the key to meeting these targets. And this rating exactly does that. It helps them understand sustainability concept at the school level itself, so that whatever they become at the end, after once they pass their school, they graduate and become a professional, they carry these sustainable learnings with them. Otherwise, what happens? Become a lawyer. I want a glass office at the end of the day. So that doesn't make sense. So these basic sustainability practices are embedded through this rating into them at the school level. Then you have GREHA for cities. This is basically a policy level evaluation of any cities, ULB, how they are implementing sustainability at the city level. Now, what happens in GREHA keeps on updating as per the Government of India requirements. As we all know, 2070 target is there of net zero carbon. So GREHA has recently last year launched by Ministry of Urban Development, the DHP program, Decarbonizing Habitat Program. Now, this is one of the only tools available which helps you calculate your carbon on various sections, not just energy and fuels. In general, what the globe does is it helps you calculate carbon in terms of your energy nexus and the fuel nexus. But this tool helps you calculate your carbon holistically, which is one, including your water, waste, transport, energy, and human lifestyle and social as well. Because we are the people who emit carbon. Individually, building cannot emit carbon. Unless we put us into the whole process, the carbon calculations are invalid as per us. To facilitate it, there is further certification, which is individual certification, which is actually getting a good traction in the market because it is a small scale implementation and people love to achieve something at the end of each financial year. So water positive certification, energy positive certification, and net zero waste. So this is individual resource efficiency certification, which is there. And lastly, Jan GREHA, which is basically small scale houses, individual houses, which are in the affordable segment. So a sweeper's house, a cleaner person's house, a carpenter's house, less than 200 square meters. And this is small scale, but we have a huge chunk of it across the country. So if that they can be sustainable, they can understand sustainability at the roots, it's easier to implement and achieve our targets. Now, in general, when you talk about a building, there are 4 stages: design, construction, operation, and maintenance. Now, GREHA helps you evaluate sustainability throughout the life cycle, as I said. So each stage is very important. Design, if design is not sustainable, nobody can make it sustainable. Construction, if design is good, but the construction practices are bad, there is lots of wastages, material losses, again, the building becomes unsustainable. Now, design, construction, both are good, but the O&M team doesn't know how to manage a building, does not teach the user how to use a building. I put down the curtains, switch on the light, I'm still working in my building. it is unsustainable. And then I will have high bills, energy bills, water bills, again unsustainable. So the processes, there's a huge detailed Griha process, how it synergizes itself with the whole rating industry. So that's the design stage where you actually handhold the projects. In the design stage itself, what you can make a project better. Then there are site visits during construction to make sure we are there to handhold you throughout the process and make sure that you buy systems which are sustainable. Now, when you go into the market, everything is green. If you go and ask the vendor what is green, nobody knows what is green. So you have to be aware what documents you have to ask these vendors when you're making a building. Okay, if I'm using a material in the false ceiling, what should I know that it is sustainable, that it is green? So it is important, the system's efficiencies, you are aware what you need to do. Then this is the basic evaluation process on the operation stage where you get a rating. And finally, once the building is rated and running for 2 and 5 years, after every 5 years, you do the audit and make a building, maintain the building green throughout the life cycle, the maintenance stage. Sorry, this seems to be doing again. Sorry. So what is the difference? What Griha is? Griha actually is nothing different. You already have lots of requirements in our country. You have the planning mandates, you have the water compliance mandates, you have the social compliance mandate, you have the pollution mandates, you have energy mandates. What Griha does is it collaborates everything and bring it in one single platter. Do Griha, you are meeting all the mandates. Do better and you get a better rating basically. Instead of running around, okay, I need to get this approval, I need to get this mandate if I'm meeting this mandate or not. So Griha does that for you. It adds all mandates at one single platter. You do Griha, you are trying to meet all mandates at least. If you're not meeting any single mandate, you are ineligible for rating of Griha itself. So what is the difference? The current system, we have the least time and cost involvement in design. And automatically what happens is the marketing cost, the construction cost, the operation maintenance time and cost increases exponentially. The sustainable buildings, the key is the design. If we give a bit time to the design is the low-cost solution to make any building sustainable. If that design becomes sustainable, automatically O&M construction, everything can be easily handled basically. So as I said, Griha is an overall holistic evaluation of project. It evaluates everything in a project: site planning, construction management, energy optimization, comfort, water management, then solid waste management, materials which you are using, even life cycle costing. So initially we used to work on embedded energy of material. What is the embedded energy of any material or things which you are using on site? Now embedded energy is a single part of the whole life cycle analysis basically. What we have gone ahead in Griha, and this is the first rating to get LCC integrated into the whole evaluation, is the life cycle costing. So it's basically a payback. If you are investing anything in any high-end system, is it worthwhile in investing in that system? What is the payback time? If the payback is above 5 to 6 years, then there's something wrong in your decision which you're making. You don't need to invest that much high cost. You will not get that payback basically. So these systems get evaluated automatically, which you are implementing. ROI gets evaluated. You have socioeconomic strategies and then performance metering and monitoring. Examples: Akshay Urja Bhavan, a very interesting example from Panchkula, hot and dry climate. Now, when you see this building, it's a glass facade. I was saying that glass facade nahi hona chahiye. It doesn't make sense. Too much of glass in hot and dry climate of India. Yes, but this is a 5-star rated building again. And the interesting thing about this building is that it's a 100% non-AC building. Okay, too much of glass, but still non-AC. How does this work? If you see this elevation, and if you see the plan, this is the glass facade. And these are the boxes which you saw in the elevation. These are called the solar chimneys. Now, this is, as I said, this is a hot and dry climate. And mind you, the copy paste of design doesn't work. So it is working because it is made in Panchkula. It will not work somewhere else. You need to check the applicability of design solutions. This building is designed as a big desert cooler. Desert cooler mein, what we used to do is we used to sprinkle water on our side panels, and the air which was sucked in through these panels automatically get cooled, and it gives you a cooled environment in the common spaces where it was installed. So what it does is, if you have glass, now this is south facade basically. Now this is a south facade, which means this will have high solar incident. Because of that, the inside spaces will heat up very fast. Then you have these solar chimneys, which are again concrete masses, which is again high specific heat. So again, it helps us increase the heat inside the space. Now what they did was these solar chimneys inside the space, they have levers on top. So all the heat which is generated in the space, it gets exhausted from the top. Now what they do is in the central courtyard, they have something called misting, literally sprinkling of water droplets early in the morning and afternoon, depending on how hot the weather is. What it does is it creates a positive pressure in the central courtyard. The courtyard becomes cooler. And this is a negative pressure because you have lots of heat and heat gets evacuated through these top levers. So wind automatically should go this side, but then you have the corridor walls. So what they did, in the corridor walls at the bottom level, they had interesting designer jalis integrated in the wall itself. So if you see the section of the room, at the left in the corridor walls, you have the bottom jalis. On the right, you have the levers. So automatically a draft is created, and that's how the building is cooled. That's it. Other thing which you see, the east and west facades, it's all buffer spaces because we all know the west has the highest heat ingress, south and southwest and west. So your staircases, your toilets, these have one, the windows are tilted towards south, so the glare is 0. Second, all these spaces are on east and west, so that heat intake is reduced. Such windows which are glare free. Now, when we talk about glare, that's a very interesting, important requirement in the building design itself. Again, an example from Maharashtra. This is Chandrapur, Maharashtra. It's a bamboo research center in Maharashtra. Now, bamboo, India is the second largest producer of bamboo in the world. And bamboo is one of the most sustainable product which can be available in the market. But we are the least user in the built environment. It has the highest tensile strength. It has the highest compressive strength. It is 100% of the bamboo is usable. The roots can be eatable. The bamboo shoots can be used different areas, walling, flooring, columns. So this is one example where bamboo is used in almost everything, whether it's roof, whether it's wall, whether it's column, whether it's flooring, whether it's furniture, almost everything. A very interesting project worth visiting. This is one of the biggest bamboo structures in our country now. A negative impact of environment on making buildings. This you can go and see over there. Actually, again, a good example from Maharashtra. This is Royal Orange County in Pune. It's a developer house. So very interesting example. If a developer can make it, anybody can make it because then it makes commercial sense. That's why he's making it. These are 207 flats in Pune. They have totally omitted cement from plaster. They have shifted back to the lime plaster. Now, lime has two important things. One, it is cooler because of the cooling property. The internal spaces remains cooler. The second is it is automatically white. So it totally does not require any painting. So 0 paints, automatically white finish. And it can be easily maintained also. So secondly, the sewage treatment plant, they have shifted towards natural STP, which is soil biotechnology. It's an IIT Bombay patent. It is maintenance free. The sewage which is generated, it is used for plantation to treat the water. This is also now being used in most of the airports because it is totally maintenance free. The NVVR, the FAB systems, they require lots of maintenance. But soil biotechnology is a maintenance free system. And it can be used by developers also because they have used it over here. It requires space, but the basement space which you give to an STP is the similar space you require for soil biotechnology as well. They have recharging water pits or 12 lakhs. What is most interesting about this project is this, the line which you see in red. Now, these are 207 flats running for last now 5 to 7 years. And mind you, none of the flats have ever paid an energy bill of monthly 200 rupees, not more than 200 rupees per month. And that's what it makes it interesting. And if you see, this is the kind of flat it is there. It is not a shabby looking flat with 200 units usage. And it is a very interesting design, electrical system design, what the developer has gone ahead and installed. What they have done is each flat has dedicated 200 units, that is 1 rupee per unit, which is being generated from solar PV and solar hot water per month, which is dedicated to each flat. What they have is something, if you see this machine over there, it has 2 lights, green light and red light. Now the green light is on when the building is being used in the 200 units, 1 rupee per unit frame basically. The moment you go above 200 units, the red light switch comes on. What it helps you is basically it helps you take a decision. Okay, I'm using more. I should go and switch off. Right now, what happens is your energy bills comes after the month of usage. So you can't do anything about it. Similarly, if you see on the left side, this is the solar hot water system. What they have done is you can control how much hot water you require, as in the temperature in your bathrooms. So what they have given is they have given a dial in each bathroom, and you can set the temperature of your hot water you require. Now, for example, if I require less hot water, say around 30 degrees Celsius or 25 degrees Celsius, I put the dial to 25 degrees Celsius. What it does is it takes the hot water from your solar hot water system. Now, if it checks the temperature of that hot water system, if it is meeting your compliance, it will directly supply it to your tap. But if it feels that it is low, or it is high, it adds the water there and there itself and give you the exact temperature which you need. Now, what it does is it reduces lots of energy from your side. But because what happens is first you take extra heat water in your bucket, then you add cold water because it is too much of cold. So it saves lots of energy in this system. Very interesting project, must visit as a developer project to see. This is a government development, which is Smart Ghar in Rajkot. This is a Griha affordable housing segment, basically. Again, a key is design, basically. This is, if you see this sections, this it reminds you of your old section of your door or window in which you used to have your ventilators, which was crucial to have natural ventilation. Now, in the modern buildings, generally you have above 10 stories. And what happens is you tend to close your windows even if the temperature is good. So these ventilators help you facilitate that flow. But with these design, they had to face the problem of dust and mosquitoes coming in. So they changed the design to slider ventilation, which has again a problem of water coming in and the wind speed still coming in. So now they have a top hung ventilator, which means it acts as a rain barrier. It helps you modulate the wind flow, how much you want, depending on the opening which you can keep. Very interesting design in each module also. What you see, these utility ducts, they have something called a centralized exhaust fan on the roof. What it does is, because of that, each flat, being an affordable housing, does not require to install an exhaust in each bathroom. So 2 exhaust costs is used from each flat. It creates a negative pressure. So the smell from bathroom and toilet doesn't go into the drawing, living and kitchen spaces. It is automatically went out from this regular duct, which exhaust which is created. It helps create a negative pressure in the bedroom and drawing room as well, which creates a natural ventilation flow within these spaces. Very interesting design, very small change can create a major impact on the comfort levels of the users who are using the building. So last 2 slides, what impact we have created. Now Griha has almost 3,500 projects plus across India, out of which around 700 have been rated. Now these rated means they have completed and received the rating. And through this, what we have achieved is now Griha has a mandate of installing renewable energy in each of the projects. So Griha has made sure that they have installed 533 megawatt of renewable energy in these 700 projects. This much of energy saved, this much of carbon emissions saved. Now, if just 700 projects in India can do this, imagine what 3,500 or 100% can do. Similarly, in terms of water, this much of water saved through 700 projects, this much of new trees planted in these 700 projects, and these many trees preserved. Again, this is just not even 0.1% of the whole built up area. Imagine if 0.1% can do this, 100% can do. Very interesting climate change implementation impact together we can do. So that's what Griha brings on picture and on board, and that's what these numbers are what Government of India reports to the global platform, basically. And that brings to the end. Thank you very much.
Thanks a lot.
Neeta ma'am, you're on mute if you're saying something.
Yes, I wanted to thank you, and it's been very interesting. And these ideas, they appear to be so simple. And I'm sure the professionals who are with us today, they will have ideas, and you're also training the younger generation and different people, especially the clients who can demand these things. So that is really beautiful. And I'm sure that now with this workshop and this conferences, people are going to get ideas, and we are going to see a positive change. So thank you. And now I'd like to mention that we are going to have a small lunch break. We have been together all morning. So we will be having, and I would like to tell you about our conference. We have made a small presentation. So that will be here and will be again at 2 o'clock with the next speakers. We have Dr. Ruchi Srivastav, who's going to speak on water management in green buildings and passive cooling designs. Mr. Aro would be speaking on proposing sustainable construction alternatives. Dr. Nilima Satyam would be speaking on good management practices for energy efficient buildings using passive cooling designs. We have Professor Jagdish Godial, who's going to be speaking on sustainable and eco-friendly concrete hollow blocks manufactured using construction and demolition waste, compiling to 3D of sustainability. Then we have Shri Ajay Ratan, who's the Associate Vice President of Tata BlueScope. He would be speaking about sustainability in construction industry, especially the materials, what materials can be used to be sustainable. And then we have the project report that CIDC submitted to the ozone cell. Professor Niranjan Swarup would be speaking on the project report, what we have studied and what were the outcomes of the report. So okay, we see you again at 2 o'clock sharp, and we will be starting our next sessions. Thank you for the time, and let's have lunch together at our places online. We are there. Thank you.
Thank you, Shruti.
Good afternoon, everybody. I hope you enjoyed your lunch. So now we can start our afternoon session and continue with the conference. We have already shared the information. I hope you all have noted it during the lunchtime that we are having a conference from 10th to 12th in Pusa Convention Hall, where we are going to have international experts, Vishkarma Awards, and various things on latest technologies. So I'm sure that you would like to join, and the information is available on the CIDC website also. For the next presentation, I would like to introduce the expert. The expert is Dr. Ruchi Srivastav. Dr. Srivastav is the principal, Parul Institute of Engineering and Technology, Baroda. She would be speaking on water management in green buildings and passive cooling designs. Passive cooling designs being our topic of the conference. So I would like to have Dr. Ruchi Srivastav's presentation. Did we have it? Thank you.
Very good morning to one and all. Myself, Dr. Ruchi Srivastav, Principal, Parul Institute of Engineering and Technology Diploma Studies, will present you on water management in green building and passive cool design. So the outline of the presentation is introduction, sources of water, water management in green building, green water harvesting, and passive cooling. So we all know that what are the different sources of water like river, lake, sea, waterfall, wetland, icebergs, delta, ponds, glaciers, oases. Almost the land is covered with water, but still we do not get the water in drinking in a proper required manner. So there are various uses of water, that is drinking, in aquatic life, swimming, fountains, bathing, construction for plants, industries, cleaning clothes, cooking, washing utensils, and so on. Now, why should we conserve water? So we know that nowadays the water is available in scarcity, and in near future it will be very difficult for our next generation to get the plenty amount of water. So it is important that we preserve and conserve water and use it effectively. So to prepare for future droughts, to guard against rising costs and potential conflicts, to preserve the environment, to strengthen communities, and to make water available for recreational purposes. That is why it is required that we conserve water. And the most important 5 ways to conserve water is we should use a garden hose nozzle when we are watering the plants. We should take shorter showers. We should have 5 different ways to wash the utensils and the clothes where minimum water is used, fix water leaks, and install efficient toilets. So my today's main topic is focused on water management in green buildings. So basically, first of all, we should know what is a green building. The word green building suggests that it may be something of trees and plants, right? But if we talk about the green building, then we can say that green building is a sustainable building that, because of its construction features, can maintain or improve the quality of life of the environment in which it is located. Now, from the figure, we can see that we are using the recreational renewable materials. We are trying to have interior wall insulation. That means we are going to save electricity. We are using solar energy. So again, we are using the renewable energy. Then we are trying to control the moisture so that plantation and trees get sufficient water. Apart from that, we are reusing the water after treating it for plants as well as in the toiletries. So when we are adopting these different types of features in a particular construction of a building, then it is called as a green building. So the 7 green building components are aluminum weather resistant insulated. Then we have got the energy efficient windows. Then we have got the what we call it as green roofs. We have got the solar panels. We have got water conservation. We have got recycling, and we have got the landscaping. So when all these things or components are there in a particular building, then we call it as a green building. So the main purpose is conservation of water is the basic principle of green building. Now, what is water management? So we know that GBWM, that is Green Building Water Management, focuses on water efficiency and conservation in buildings at the city level. Now, it has got a unified focus on promoting green buildings by undertaking a series of committed activities through research, policy, awareness, and capacity building. So, in green building, the conservation of water is the basic principle of green building. One of the best examples of green building practices is rainwater harvesting. We know when we have got a heavy rain or after certain duration of rainfall, there is a runoff which is totally waste. So in that particular case, if we want to use that runoff in the later cases, that is in the summer, then we can go for one particular technique that is called as rainwater harvesting. Now, basically, if we talk about the rainwater harvesting, then especially in areas that are dense with concrete buildings, the rainwater that falls flows away and is lost forever. Smallest of the buildings should invest in rainwater harvesting that can provide a steady source of water, which can be filtered and refiltered to make it possible to and portable for the human consumption. Apart from that, this water can also be utilized in restrooms and for watering the garden. So rainwater can be purified using simple techniques. So in today's presentation, the main focus is rainwater harvesting and passive cooling, that are the 2 main components of the green building. So now the rainwater harvesting, we can see in this particular figure that there is a heavy rainfall, right? And the water is over the land, which is called as the runoff. Now in this particular case, in the terrace, we can have a provision through which a pipe is connected to a tank. So whatever runoff is there, the water will go through the pipe to the particular tank, and from that particular tank, the water can be filtered and refiltered and it can be used. Sometimes in the rainwater harvesting, instead of this particular tank, we are having a storage cell where we are providing different layers of purification, that is stones, pebbles, and layers of sand, which can directly purify the water. So rainwater harvesting is nothing but the collection and storage of rainwater that runoffs from rooftops, parks, roads, open grounds, etc. This water runoff can be either stored or recharged into the groundwater. So the process includes the accumulation and deposition of rainwater for reuse on site rather than allowing it to run off. Rainwater can be accumulated at a reservoir with percolation or collected from dew or fog with nets or other tools. It uses include water for gardens, livestock, irrigation, domestic use with proper treatment, indoor heating for houses, and so on. The harvested water can also be used as drinking water in long-term other purposes such as groundwater recharge. We also know that the groundwater level is reduced or depleted a lot. So to recharge that groundwater, we can go for rainwater harvesting and we can recharge the groundwater. So this diagram is an overview of rainwater harvesting. We can see over here that this is an overhead tank or a pure water for use. This is the ground level, and below ground level we have got underground sump, where the raw water from the runoff or from the terrace is collected, and this raw water can be used for plants and vehicle washing. Also, it can be easily gone to the water sump, and it can then be used for recharging the groundwater. So the advantages of rainwater harvesting, in simple words, we can call it as portability, irrigation aid, less utilization, economical, serving multi-purpose, reduces dependability, stormwater retention, natural and ecological, and water energy nexus. Now, what are the different types of rainwater harvesting, right? So we have got 4 or 5 main types of rainwater harvesting. The first rainwater harvesting type is water butt. Now, what is this particular water butt? So it is the basic form of harvesting, that is humble garden water butt, where the water is collected in the container from drain pipes or natural rainfall and is mainly used for watering of the garden plants. Pairing the water tank with a rainwater filter can further improve the quality of harvested rainwater. So this is the bucket where the water is collected with the help of pipe, and it is stored in this particular water butt. Then second is the direct pump, that is submersible. So we know that we have got submersible pumps. So below ground, we are trying to fix a submersible pump. So it is most common type of more professional rainwater harvesting system, where the pump is located within the underground tank and harvested water is simply pumped directly to the WCs or other appliances. If the tank should be in danger of running dry, a small amount of water mains is fed to it in order to maintain the supply. For commercial projects, such system is arranged. Another is suction pump. So this system differs from the submersible pump in a way that it is not inside the tank, but instead is located within a control unit within the house. The unit also deals with backup from mains water supply, so there is no need to send mains water down to the tank. Then gravity. We know that the water flows through gravity. So in some situations, it may be possible to have a system that functions purely through gravity, requiring no pump and therefore no energy use. So we are saving the energy. With this arrangement, rainwater is collected from a part of roof, which has gutters above the filter, and collection tanks, which are turned above all the outlets. So this arrangement is only ever possible where the storage tank can be located below the level of the gutters. We can see that this is the gutter line, and below that gutter line, we have provided this particular storage tank. So only the power of gravity is needed to feed the collected and filtered water to various parts of the home for the use of it. Indirect gravity, so this system differs that the harvested water is first pumped to high level tank, and then it is allowed to supply the outlets by gravity alone. So these were some overview about the rainwater harvesting and the types of rainwater harvesting. Now, the second green building component is the passive cooling technique. So basically, what is a passive cooling technique? So passive cooling uses free renewable sources of energy such as sun and wind to provide cooling, ventilation, and lighting needs for a household. This additionally removes the need to use mechanical cooling. The diagram or the figure itself shows that this is the summer sun, and it is striking this particular exterior wall of the building. So we have to provide the shading in such a way that the internal temperature of the building is low and the effect is cool. This can also be done with the help of louvered windows, which can be in the form of vertical and horizontal. Then the solar panels can be used, or the insulation can be used for decreasing the temperature up to 4 degrees. Then summer cooling breezes should be there so that the inlet and outlet flow of the air is such that there is a cooling temperature within the inside of the house. So all these particular technique refers to the passive cooling. So if I want to define what is the passive cooling, so it means using design choices to reduce heat gain and increase the heat loss. Now, we must have heard about active cooling and the passive design. So the diagram itself shows that in the passive design, we are using these sources of natural ventilation, whereas in the active, we are using the sources like fan or air conditioner coolers. So if I want to define in a one word, passive design results when a building is created and simply works on its own. The plan, section, material selection and sitting creates a positive energy flow through the building and save energy. And active design uses equipment to modify the state of the building, creates energy and comfort, that is fans, pumps, etc. So passive building requires active users to open and shut windows and blinds. Thus, active cooling performance, the operating system turns on a cooling device such as fan. Passive cooling decreases the power consumed by the devices in a thermal zone. Active cooling increases the consumption of the energy. So now what is a passive design? So passive design is basically based upon the climatic conditions. We should see where we are designing this particular green building with passive design, whether it is an arid zone, whether it is in a temperate zone, whether it is in a zone where it is having a very hot climate. So first consideration is climatic conditions. Second is we should make an attempt to control comfort, that is heating and cooling, without consuming fuels. We know that the fuels are now available in a very scarcity part. So minimum use of fuels should be there. The third is orientation of the building. It should be such that it controls heat gain and heat loss. Then the shape of the building should be such that it controls the airflow. Apart from the shape, material is very, very important. We should use such materials which control the heat, which tries to reflect back the sun rays. Free solar energy for heating and lighting. Then maximum use of free ventilation for cooling and use of or louvers to control the heat gain. So when all these parameters are considered in a particular design of a building, then we call it as a passive design. So many types of passive cooling strategies are there. So design strategies that minimize the need for mechanical cooling includes proper window placement and daylight design, selection of suitable glazing for windows or skylights, proper size shading of glass when heat gains are being avoided, use of light or reflective colored materials for building envelopes and roofs, careful setting and wise orientation decisions alongside appropriate landscaping design. So this figure itself shows that whenever that we are going for a passive design, we should go for high solar reflection where the sun rays are reflected back and almost 4 degrees centigrade temperature is being reduced. Double glazing should be provided so that the heat rays do not enter directly into the residential building. Green roofs should be provided, which can decrease the temperature of the internal parts or components of the building. Wind catchers should be there. Then louver shading devices should be there. Insulation should be there. Evaporative cooling should be there in the form of what we call it as water coolers and indirect radiant cooling. So louver shading device, we can see from the figure that these are the louvers that are trying to prevent the sun or block the sun in summer and yet allows it to enter in the winter. So these are the horizontal louvers, these are the vertical louvers, and these are basically provided to block the sun in summer and give the sunlight in the winter. Now double glazing, it is basically, if we see this particular section of the double glazed window, we can see that these are the two glasses which has got a space. This space can be filled either with air or gas, and then this particular double glazed window has got benefits like year-round comfort, UV protection, enhanced security, illuminate your space, and reduce outside noise. So the double glazed glass, which is also known as insulated glass units, comprises of 2 or more panes of glass separated by air or gas, as I already mentioned, which is filled cavity that is completely sealed, forming a transparent insulating barrier between the interior of your space. The second natural ventilation is wind catcher and cross ventilation. We know that cross ventilation is such that we provide the openings in the building in such a way that there is cross ventilation of the air, that is hot air and the fresh air. It removes the hot air and brings fresh air to the building, which also lowers the temperature so that the loading energy will be reduced. The second part is the chimney ventilation, where we can see that vertical buildings, vertical ventilation flows to the chimney effect. Now, cold air exerts pressure under the warm air forcing and it goes up, as well as in induced ventilation. However, in this case, open areas by the protect center or towers allow the same air to circulate through the environment, leaving through the roof or zenithal opening or so on. And the last is the wind tower or wind catcher, which provides a low carbon ventilation system which can deliver fresh air to the occupant without using any kind of mechanical system. The third is green roofing. You can see the diagram which has got n number of layers, where the green roofing has the first and the topmost layer as the plantation. The next layer that we can see is the green roof substrate. The third layer is drainage or retention, because when we are watering the plant, it will have water. So drainage retention will reduce the efficiency of the green roof, which can be done with the help of geotextile. Then we have got the next layer, that is protection geofabrics or geotextile, which is used for attenuation of void former. Then we have got next layer, which is high crush strength drainage layer with bonded filter geotextile, which used as waterproofing or insulation. And the last layer is the concrete roof structure. So basically, a green roof can be defined as a building roof covered by grasses or plants which lie over a waterproof membrane. The roof is one of the main solar heat gain points in a building, right? Because the sunlight is directly striking on the terrace of a particular building. So by using a high level of insulation, it can reduce heat conduction to the interior of the building. The other important sustainable points are producing oxygen for the environment, reducing the heat island effect in the urban environment, and reducing air temperature. Thus, the main advantages of green roofing is reduce the carbon footprint of the building, improve stormwater management by reducing runoff, reduces the effect of the urban heat island, improve biodiversity, enhance the insulation properties of the roof, and provide additional space for the urban areas. So the next passive design contains insulation. Now, insulation is we are trying to have or reduce heat loss or gain through a building envelope. So insulation acts as a barrier to the heat flow, reducing heat loss in winter to keep the house warm, and reducing heat gain in summer to keep the house cool. So we are using different type of materials, foams for insulation purpose. The next is the evaporative cooling via fountains. So generally, some people have the concept that when we are using fountain, we are misusing the water. But if fountain is used in a proper way, it can cool the air when it combines with water and evaporates, leading to a reduction in the air temperature. So to obtain the best effective cooling by this method, the interaction between water and air needs to be as widespread as possible. And the last is light color coatings with high reflection, right? So the diagram itself shows that the sun is striking the terrace. If we are using the light color coatings on the terrace, then the sunlight reflected is greater than 0.7 and emitted thermal radiation is greater than 0.75. So the temperature over here from 34 degrees centigrade is reduced to 27 degrees centigrade. That means 4 to 5 degree temperature is reduced. So exterior walls exposed to solar radiation can transfer a huge amount of heat to a building. This therefore affects the temperature of interior spaces and can also decrease the comfort level temperature. To reduce heat transmission, solar reflecting coatings can be used to reduce the temperature of the interior in addition to the cooling loads. And it is found through a study that around 4 to 6 degree temperature is reduced. So with this, I request all my participants and viewers that we should try to go for a green building and we should start it from our home. In a very small and simple way, at least we can go for rainwater harvesting. We can go for passive cool designing, that is solar panels. Government has also given us subsidy for the solar panels so that we are trying to use our natural source of energy and reducing the electricity consumption. With this, I thank you all.
Thank you for a very interesting and enlightening presentation. And I'm sure the viewers are going to benefit from this and implement these in their next designs. And we really do need to conserve our water as the water table is going down and we're going to have much problems. For the next presentation, I'd like to introduce Mr. Aro Swaroop. He's going to speak on proposing sustainable construction alternatives. Mr. Aro Swaroop is serving as a manager in CIDC. He has completed his master's in construction engineering management from the University of Texas at Arlington, USA, and is currently pursuing his PhD from the University of Kansas. So now we are going to listen to Mr. Aro Swaroop. The topic is proposing sustainable construction alternatives. Can we have the presentation, please?
Greetings, everyone. Thank you for joining the conference event. And I'm glad to have you during the session as a respected audience. Thank you very much for joining us today. And for the topic that I'm going to be discussing with you is going to be proposing sustainable construction alternatives. Over the past couple of months, CIDC has been working on identifying many sustainable alternatives for construction process that help in phasing out the ozone depleting gases, ozone depleting substances, and making sure that passive cooling is something that should be considered while designing your building or structures or any construction project, basically. So now that we have identified, how do we pitch these ideas? How do we pitch these alternatives of construction to the next person, to our clients or our end users of these buildings? That comes as a big question. So this session is all about how do we do that? What are the steps that we should be doing in order to get all of our alternatives in the right place? So let me go ahead and move on. The agenda for this presentation will move in such a way that we'll have, first we'll discuss what do we define as a sustainable alternative for construction process. And then why do we find these alternatives as essential, or why do they serve as a vital alternative for the construction process? That is something that we'll discuss. How do we propose sustainable alternatives? And then how do we calculate their return over investment? How do we say that are they worth it? Are they worth the money that we are investing in? And then I'll go over a case study that I've done in my time in the United States. I've been working closely with with the team, and we proposed a number of sustainable alternatives for the construction process. And in a way that when we propose these alternatives, we added the element of finances to our proposal. And this case study is about that proposal right here. So let me quickly start. The first thing I would like to go over is, what do we define as sustainable alternatives for construction? So the alternatives for a construction project are basically parts, or a single part or multiple parts of a whole system, which is our construction project, where we have the ability to switch to a better way of achieving the endeavor which is devoted to that part or set of parts, while making the whole process eco-friendly, making sure the process does not have major carbon footprint associated with it. So this is the part where we discuss what can be the dimension across which a project can be divided, and sustainability can be achieved across these dimensions. So there are 6 zones in a construction project, or 6 dimensions in a construction project, which can be targeted for adding sustainable reforms, making your project valuable in terms of sustainability. First thing would be location, and then size, water efficiency, the sustainable size, water efficiency, energy and atmosphere, materials and resources, whatever is going in the project, and indoor environmental quality, making sure that even in process of making the whole construction process or post-construction, the building sustainable, it should not be done at the cost of indoor environmental quality. So that is also an essential dimension in making the project sustainable or eco-friendly. So why are sustainable alternatives essential? Moving from this part, we observe that there are several reasons why one should go around and discuss these. First thing is to offer a greener outcome for the project, to offer lesser environmental damage that is done within the construction process. We offer sustainable alternatives. Then making sure the local authorities, whatever authorities require, whatever the local authorities require in terms of environmental impact and the other analyses, whatever the local government, the municipal corporations or the state governments require out of a project, that can be achieved, or at least a better picture of a project can be presented when we offer these sustainable outlooks, the alternatives. And then there's a major one, it is to save the post-completion operating cost, which implies that if we choose if we choose an aspect of the project where sustainability can be achieved, where a greener way of achieving the same goal can be done, it's more likely to save on the costs that are done to the environmental damage. And beyond that, there are other monetary values that are generally associated with these benefits. For example, there is this one big thing, this one common thing called solar energy or solar panels that people are very familiar with. With solar panels, what usually happens is that initial investment is high. Definitely, you need to construct those panels. You need to make space for them over your roof and all. But later on, having those solar panels gives you a better benefit, a higher benefit of having them in terms of energy saving. Not only you are reducing your own energy bill, but you're also contributing to the local energy entity by sharing whatever energy that you have generated by solar panels. It saves the post-operation cost. That is what I mean by this point. Then to develop more client-contractor relations. Believe it or not, the contractor and client, they do have they will observe a better outcome, like better relation-based outcome, better contractual and beyond contractual, a healthy stakeholder relationship if more society-oriented goals are achieved through their project. So that is where sustainable alternatives are a way to go for making sure that we have a lot of better things going on for our project. So now question arises, how or what do we do? What are the steps that are essential? So the first step would be to observe the project through the dimensions of sustainability, like the 6 dimensions that I mentioned in my first slide. This slide right here. These 6 dimensions: the location, sustainable sites, water efficiency, atmosphere, energy, materials resources, indoor environmental quality. You need to observe. So basically, you have a team. The project team should divide these categories among themselves and look at the project drawings, look at the project on itself, and then look at the positives, look at the way where all of these categories can be achieved. Like all of these categories can be made a little more sustainable. And the activity should be like everyone in the team should present one idea within the dimension that they are applying. So for example, if I'm in a project team and I choose that, okay, energy and atmosphere is something that I can take over. In that case, I'll look at the area, look at the drawings wherever I see that, okay, for example, natural lighting can be increased in this house by adding reflective shells in this place. So that itself is another big example that I would recommend that I will identify and that I will observe first. So the second part is actually identifying, which I just mentioned, which is now that, for example, I'm assigned the area of energy and atmosphere, and I observe that there is a light reflective shell that adds to the natural lighting of a building. So I will try to identify it and make sure that I note it down for my proposal. I'm contributing as a part of my proposal the idea of light reflective shells, and so I'm identifying these. The next part would be researching the effect and the pricing of the identified alternatives. So now that I've identified okay, light reflective shells is a good idea, but is the effect, how massive effect are we observing? Am I illuminating the entire building with my light reflective shells, or is it not very effective? Like the paint and all, are they hyper reflective or are they not reflective? There's a lot of dimensions including. So you need to identify the effect and then the pricing associated with it. Like how much will it cost me to put reflective shells on all of my windows? So that's a big question you need to realize before you move on. And then the last one is run the cost analysis, cost benefit analysis numbers. So now that you have identified that, okay, let's say this is possible that there are X amount of windows in my place and X amount of windows, and these many light shells are required, light reflector shells are required. So how much is it going to cost me? How much is going to be the installation? Are there any maintenance activities involved? These are the things that I would like to know before I move on. So I'll note down these costs, and then I'll do a cost benefit analysis, which is basically I'll make sure how much time do the benefits, do I get the benefits out of these things, and how much benefit do I reap out of these light reflective shells, and how much time will it take for me to recover the cost that I've already put in while installing these light reflective shells. That is what we are planning to present in this session. So the formula that is essential over here is this formula right here, which is P over A is equal to 1 plus I to the power of n minus 1 over I times 1 plus I to the power of n. It is a simple compound interest. It is an easy formula for compound interest. Basically, these are the terms that you need to understand, which is P is the amount that you're putting in initially of your entire investment. A is the annual returns from saving, which is like on an average, not on an average, completely throughout the year, how much returns you are getting. That is the A. Then N is the number of years that we are observing till these benefits, the savings that are observed for installation, for these types of installation. These types of savings are the ones that we realize how much do these savings break even our initial investment. So by that I mean, we say A as annual return, how many years will it take the annual returns to cross our initial investment, and I is the observed interest rate, which depends. For example, if you keep that money in a regular checking account or the account which is used for direct deposit, your deposits account, that account generally gives you an interest of like 1% or so, and that it depends on how you rate the value of your money, how you rate your interest. So that can be changed across. But the variable that we are trying to identify is N. How many years will it take for us to start making value out of these investments? The case study is a residential. So now I'll go to the case study, and I'm observing that I'm quite limited on my time, but I'll continue. The case study that we have over here is a residence house, which is supposed to be built in Arlington, Texas. And since it's in United States, the costs that are proposed and the sustainable alternatives that are being proposed in this will be in dollars, but around conversion and around the process, I think a similar kind of trend or similar ratings can be observed in India. So these are some brief project bios that the project is located in Arlington, Texas. It is a residential housing, in need of a sustainable construction. My team's whole thing was to propose sustainable alternatives. These were the basic areas. These were the basics of the project. Basic drawings. It's a 3-bed, 3-bath house, modular kitchen, XYZ information. Moving on, we proposed the sustainable alternatives in the same way that methodology that I mentioned before. First, we divided the project into multiple ways of observation. We observed it using these 6 dimensions: location, sustainable site, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality. So in these cases, usually in a lot of cases, location is a parameter that's generally out of the control of contractors, but maybe in control of the client. The client has the whole control over location and how he picks how the contractor, he, she, or them, whoever picks the location, how do they make sure that the location, it is beneficial to the user of that building, and it's not causing them more strain in order to commute. When we talk about location, the biggest thing that location can contribute to is the commute that is associated with it. In this case, it's residential housing, so that's considered a home for someone, and for them, the accessibility for that particular house to the nearest bus stop or the nearest public transportation system. That is where the location factors come into play. And in this category, the activity proposed that we offer, we request from the local city or the local municipality to adjust or moderate the bus routes that are associated with that particular location in order to give more access to public transportation. Then comes the sustainable side, which is the ecological impact, which implies that how does the construction process the sites become more green or more sustainable. And in this process, we came across the idea of vegetative green roofing. In this case, what we discussed was having an entire pond light, not pond light, sorry, green light or a garden type light on the roof of the housing. And for that, it was there were a couple of things that were required. First, the initial investment for the installation, and then the second part was the irrigation for that particular area, because it's plant life. It requires irrigation. It requires water. It does require water system. So these were the costs associated with them, and the pricing was identified as $12,000 for the initial installation, with $450 per year for as the savings were identified. The operation and maintenance was the cost that I was referring to when I said irrigation system and water, the cost of water and everything. The entire annual cost was like $120, and $450 was the benefit, a realized benefit out of having a vegetative roofing, because having a vegetative roofing means you get the insulation which is caused by the roots of the plant, and beyond that, it's the passive cooling effect that the plants have when it's heavy sun. So because of that, the benefits were observed in form of the reduction in the cooling. The next category that we discussed is the water efficiency in this project. Over there, we proposed 3 activities that can reduce the water bill and make sure the water consumption itself is decreased. First thing was replacement of the old dishwasher with water efficient, replacement of the old proposed dishwasher of the house, which was like in the drawings it was proposed that we have the water efficient, the new rated efficiency rated dishwasher, which is power efficient as well as water efficient. Like the heat coil should not draw more power, and the dishwasher should not draw more water out of the supply, and it should be detecting leaks and it should be self detecting leaks, and that will reduce a lot of operation and maintenance. And then there was a sink and flush in the same water closet unit, which is basically combining the toilet units where the sink is separate and the water closet is separate, and they combine it into one where the water that's used in the sink is used to refill the water, refill the flushing part of the water closet, and then replacing the idea of sprinkler system as manually operated, and that with the automated sprinkler system to make sure that water is not being used with water is not being overused or recklessly used. In this process, we identified the costings for each of the alternatives and initial cost, the operation and maintenance cost, and the benefits. So that is there. We have observed that, and this is the example of how can the sink in the toilet and the water closet can be combined. Basic idea is to use the water supply from the inlet, and that the used water will be used for flushing later on. So the whole idea is to conserve, reduce the connection that will come out of the water that will be separate for the sink and the water closet, and making sure there's like a lot of savings of water. And it's basically, it came down as like $41 for the entire year, but the initial investment is also very low in this. So automated sprinkler system is another aspect. I'll not go into details because I'm kind of bounded by the time. And then usage of smart LED lights is another aspect. Now the next category was energy and atmosphere. Over here, we try to make the buildings energy efficient, reduce the use of fossil fuels, and direct like power consumption, reduce the power consumption, and use natural aspects. So first thing was replacing LEDs with incandescent bulbs. The use of light reflective shells was another idea that was proposed. The filters for exhaust, in order to make sure that kitchen and garage in the US, there's a lot sometimes a lot of smoke, and smoke is produced out of which can be filtered out. And so that entire process was in order to make sure the smoke is reduced, the filters were introduced for chimneys. And then the biggest one was solar panels. And solar panels is something that could be associated with a lot of project sites, with a lot of construction project, pre-project as well as post-project. People should move to solar because that's not only energy saving, but also it reduces your consumption from the direct grid. Beyond that, you get to be a contributor back to the grid, and the whole aspect of burning fossil fuels with each house getting its own solar power reduces more and more. So that is the, and then materials and resources is another aspect where we propose different alternatives of materials which can be more eco-friendly. The manufacturing is more eco-friendly, and they are either recycled material, for example, third level bricks, the Jhama bricks that are used in foundation, that itself is a sustainable way of looking at construction. That we are recycling the bricks that were broken and damaged, and now we are using them for foundation. So that is another idea that can be phased out. Then materials and resources is the same thing. And then indoor environmental qualities, where there's a lot of debate going on, and how can we improve the environmental qualities, indoor environmental qualities. And these are ideas for post-construction activities, which will include centralized thermostat. Basically, indoor sensors should be fit to the sensors which detect the presence of a person should be fit to the indoor facility, so that these indoor systems like lights, the fans, the air conditioning, they should not be operating when no one is around. Going on, there is the suggestion of having a plant, and the whole idea of having the benefits of having an indoor plant is another idea for post-construction. The IEQ is this category is generally considered for post-construction activities. So this is the way we propose alternatives. Usually what we do is we list out all the alternative items that are there in all categories. And then from there onwards, we list out the cost throughout all the costs, and we get a total, total cost, which will be initial investment that as a project owner or a project client, or even the end user, I am offered to invest that this is the total amount that these XYZ amount of alternative items will cost me. And then there is the unit of how many items are for each type of item am I going to install, the operation and maintenance cost, and the annual saving. So we add up all the annual savings, and then we subtract all the operation and maintenance costs, and then we multiply, then we do the whole investment, then we calculate the entire figure using the formula, which is this one right here. P over A is this ratio. And over here, I've drawn the cash flow diagram for the same, where this is our, P is our initial investment. This is the money we put in the beginning, and this is the annual savings that we are generating every year. And it takes almost 17 years. Over Excel, the formula is a formula that can be used for calculating, if you know this value, and the interest rate. You can use the formula in Excel and plug in these three numbers, which is N, T, E, R, and you plug in these three numbers, the principal, the amount, and interest rate. You'll get the period of return. You'll get the period when your investments start breaking even, and they'll save you more and more money. They'll start making money for you. So that is where these are the benefits. These are the entire cost, and I've tabulated. Usually these can be done over Excel as well. You are more than welcome to contact me and request for this, and I'll be happy to share the same spreadsheet for your utilization. You can use the spreadsheet as it is and change your values accordingly, and change the dollars to Indian rupees, and have these things used for pitching out your own sustainable ideas. And that's all I have for today. Thank you very much.
Thank you. This is another practical presentation with ideas that can be implemented and should be implemented. And I think that with all these discussions, things will start changing. The next presentation, we have Dr. Nilima Satyam. Dr. Nilima Satyam is a professor in the Department of Civil Engineering in Indian Institute of Technology, Indore. She has a PhD in engineering from Indian Institute of Technology, Delhi. She has done her MTech also from IIT Delhi, and her BTech was from Sri Venkateswara University, Tirupati, India. So now we'd like to listen to Dr. Nilima Satyam. Can we have this?
Namaste everyone, and first of all, myself Dr. Nilima. I'm a professor at IIT Indore. And thanks to CIDC, especially Swaroop sir, for inviting me to give a talk, and Mrs. Lakshmi also, on good management practices for energy efficient buildings using passive cooling design. So this is the topic of my today's lecture. So this is an overview of the presentation with a little bit of introduction on what is passive cooling or space cooling and how to achieve energy efficiency through its design or design or building automation systems that we have, which can create better health and comfort, and what is the energy course and consideration we have, and India's plan or vision to phase out this HCFCs, and these a few case studies which are very classic case studies which we can implement in our projects and the final conclusion. So we know that buildings are responsible for a significant portion of global energy consumption and greenhouse emissions. So according to the International Energy Agency, that is IEA, building account for about 28% of global energy consumption and 17% of global greenhouse gas emissions. And these energy efficient buildings can help, reduce energy costs for building owners. So because traditional cooling methods such as air conditioning can have a negative impact on indoor air quality, we know that it gets recycled, etc., which can cause several health issues to the occupants. And here, energy efficient building can help reduce the amount of energy that can be consumed and also lower the greenhouses. So what are these energy efficient buildings? Energy efficient buildings are designed and constructed to use less energy and resources than the conventional buildings which we are generally using now, while still providing the same level of comfort and functionality for the occupants. And these buildings achieve this through a variety of design features, including materials, technologies that minimize the energy consumption and of course the waste. And they can be designed by using high quality insulation materials, sealing gaps, and cracks, since energy efficient buildings can better retain heat in the winter and cool air in the summer, which can reduce the need of either heating or the cooling systems. So using this efficient heating, ventilation, and air conditioning with HVAC systems, energy efficient HVAC systems, can use less energy to achieve the same level of comfort as the conventional systems. If you see in this image one, energy efficient buildings, they behave differently. That is like outside temperature based on winter, summer, or whatever the season. All the variation of the temperatures when it comes to release and absorption of heat. And this energy efficient building will minimize the power usage while responding to the external fluctuations in the ambient temperature. So wherever in the second one, an ideal energy efficient building should inculcate different types of tools used in space and passive cooling also, as you see here. So this is actually the response of energy efficient buildings against heat in the night time, daytime, during summers and the winter. So these are all basically energy efficient buildings could increase using steps like you can reduce heat demand, reduce cooling demand, and we can reduce energy use for lighting purpose, and so that natural light can come in, and also reducing energy use for heating water, good housekeeping and people solutions. It can also reduce the energy requirements for ventilation. So overall, they can be designed and constructed to optimize the performance while maintaining the comfort and the functional indoor environment by the people. And by incorporating a variety of design features, materials, technology, we can significantly reduce the energy consumption and greenhouse gas emission, leading to cost saving and the environmental benefit. So the next one is like how to achieve that. How to achieve this energy efficiency in buildings, cooling systems, ventilation, they need to be taken care and can be done by two ways. One is like space cooling and the passive cooling. So further, space cooling and passive cooling are used to optimize energy efficiency by considering energy efficient HVAC systems, building automation systems, DAS. Since invention, majority of refrigerants have been using harmful coolant, but after Montreal Protocol binding, there has been modifications in their compositions or non-HCFCs like low GWP refrigerants have been focused by manufacturers, etc. And a good management practice should include framework and of course the guidelines by the government authority to direct manufacturers or the designs to follow a particular, engineered codes and the consideration. So this passive cooling, which I'll be discussing, refers to the decision of buildings and the structures to take advantage of the natural process such as conduction, radiation, ventilation to cool the indoor space without actually using the mechanical systems of electricity. So, for example, this passive cooling techniques include shading, insulation, natural ventilation, and evaporative cooling. So, in summary, I can say that it's a natural, energy efficient approach to cooling indoor spaces, while space cooling is an active process. So that relies on mechanical systems and of course the consumption of the energy. So this can be done like this, like proper natural ventilation, that you can design the building that allows for the free air of flow through the building, which can help to cool indoor spaces, and proper shading. So building orientation and shading devices such as overhang, canopies, or screens can help to reduce the direct sunlight and the heat gain. And effective evaporative cooling, the use of evaporative cooling techniques such as wetting surfaces with water can help cool indoor spaces through the process of evaporation. And thermal mass, use of materials with high thermal mass such as concrete, stone, or any other can help to regulate indoor temperatures, which can absorb that heat during the day and it can release during the night. So some of the design considerations for this. So there are three key design considerations for passive cooling. One is like orientation and the building envelope, and of course the materials part. So first, if you see the orientation of building is an important consideration, as we all know, for this passive cooling, and they should be oriented to take the advantage of prevailing winds, which can minimize exposure to direct sunlight. That means in hot climates like some parts of South India, etc., buildings should typically be oriented with a long axis, which can face east-west to minimize the solar heat gain on the south-facing walls. And the building envelopes includes the walls, roofs, windows, and doors of the building. To maximize this passive cooling, the building envelope should be designed to minimize the heat gain and, of course, maximize the natural ventilation. So this can be achieved through the use of shading devices such as overhangs or something to block the direct sunlight. And coming to the construction materials, like a lot of materials, like new materials are coming up, the choice of this is an important consideration. And as I already said, like materials with high thermal mass,
Any problem, Suchita ji? Go on.
Excuse me. There is some internet issue and we're just going to start it again. Just give us 5 minutes.
Thank you, Suchita ji. Thank you.
Can anybody hear me?
Yes, Lakshmi ji.
I am Dr. Kumar speaking. There is some internet issue in our area, I guess. We are trying to revive it. And in case we are not able to, we would be putting the presentations on CIDC YouTube. But please bear with us. Another half an hour, we'll keep on trying, and we're looking at the issue in detail, and we are working on it. Thank you.
Framework and of course the guidelines by the government authority to direct manufacturers or the design to follow a particular engineered codes and the consideration. So this passive cooling which I will be discussing refers to the decision of buildings and the structures to take advantage of the natural process such as convection, radiation, ventilation to cool the indoor space without actually using the mechanical systems of electricity. So, for example, this passive cooling techniques include shading, insulation, natural ventilation, and evaporative cooling. So, in summary, I can say that it's a natural, energy-efficient approach to cooling indoor spaces, while space cooling is an active process. So, that relies on mechanical systems and, of course, the consumption of the energy. So this can be done like this, like proper natural ventilation. That you can design the building that allows for the free air of flow through the building, which can help to cool indoor spaces, and proper shading. So building orientation and shading devices such as overhangs, canopies, or some screens can help reduce the direct sunlight and the heat gain. And effects of evaporative cooling, the use of evaporative cooling techniques such as wetting surfaces with water can help cool indoor spaces through the process of evaporation. And thermal mass, use of materials with high thermal mass such as concrete, stone, or any other can help to regulate indoor temperatures, which can absorb that heat during the day and it can produce during the night. So some of the design considerations for this. So there are three key design considerations for passive cooling. One is like orientation and the building envelope, and of course the materials part. So first, if you see the orientation of building is an important consideration, as we all know, for this passive cooling, and they should be oriented to take advantage of prevailing winds, which can minimize exposure to direct sunlight. That means in hot climates like some parts of South India, etc., buildings should typically be oriented with a long axis, which can face west, east-west to minimize the solar heat gain on the south-facing walls. And the building envelopes includes the walls, roof, windows, and doors of the building. To maximize this passive cooling, the building envelope should be designed to minimize the heat gain and, of course, maximize the natural ventilation. So this can be achieved through the use of shading devices such as overhangs or something to block the direct sunlight. And coming to the construction materials, like a lot of materials, the new materials are coming up. The choice of this is an important consideration. And as I already said, like materials with high thermal mass, they can absorb and store the heat during the day and during the night. and reducing the need for some external mechanical cooling systems. So overall, the design considerations for passive cooling are aimed at maximizing the natural ventilation, reducing heat gain, and improving the thermal comfort based upon the ambient temperatures. And by incorporating these design strategies, it is very much possible to significantly reduce energy consumption and improve the occupants' comfort without the need of mechanical cooling system. So, space cooling. Space cooling, it refers to the use of mechanical systems such as air conditioners or refrigeration to cool indoor spaces. And it is an active process that requires energy to operate. And it involves usage of refrigerants like the CFC, CFC, but the technology has been phasing out nowadays, so we need better options in space cooling. And this can also be done by giving importance to passive cooling. If you see the HVAC, that is heating, ventilation, and air conditioning systems, they are designed to consume less energy while providing the same improved level of comfort compared to the traditional HVAC systems. And these are aimed at reducing the energy consumption and the greenhouse gases. Some examples, the geothermal heat pumps. So these systems use the constant temperature of the earth to heat the cooling buildings. They work by circulating water through pipes buried underground, and which absorb heat from the earth in the winter and release the heat in the summers. So air source heat pumps, these extract heat from the air outside the building, transfer it inside during the winter, and extract heat from inside and transfer it outside. So solar thermal heating systems, these are like solar collectors to absorb heat from the sun and transfer it to the heat exchanger, which can be transport the heat to a hot water tank or radiant flow heating system kind of thing. So this is the same energy efficient HVAC systems which I just explained you. You can have it like high efficiency furnaces or the boilers, energy recovery ventilation systems where the heat recovery or technology to precondition incoming air or reducing the need of cooling, and smart thermostats that are advanced algorithms or the sensors to optimize heating and the cooling settings, and it can reduce energy consumption and improve the comfort levels. So overall, the high and efficiency HVAC systems, they offer a number of benefits, including the reduced energy consumption, lower the operational cost, improve the indoor air quality, and also reducing the greenhouse gas emissions. So it is very, very important components of energy efficient building design and can contribute very significantly in achieving the sustainability goals, UNDP goals. So building automation systems, the overview of this intelligent control systems for HVAC, lighting, and other building systems. These are very intelligent control systems and that automate and optimize the operation of various building systems, including HVAC, you can control your lights, you already know for the music, security, and access controls. They control a central controller and which is connected to sensors and control device through the buildings. Right now, Alexa as a people are using to control that. PAs can be programmed to monitor adjust HVAC systems, lighting, etc., based on occupancy, time of the day, and of course the other factors. So some of the examples and demand controlled ventilation, where this technology adjusts the amount of outside air brought into the building based on occupancy and other factors, improving indoor air quality while reducing the energy consumption. Occupancy sensors, these sensors detect the presence of occupants in a room and it adjusts the temperature and lighting settings accordingly. And it also reduces the energy consumption for unoccupied or unused. Variable frequency drive these devices, they adjust the speed of the HVAC system components such as like the fans or the pump to match the need of the building in reducing energy consumption and of course improving the overall efficiency of the system. So these are other daylight existing use the daylight things and time scheduling where the technology turns lights on and off based on pre-programmed schedule, reducing the consumption, especially when the rooms are not in use. So overall, the PAs can improve the building efficiency, energy efficiency, and reduce operating costs, electricity bills, and of course improve the comfort of the occupants. It's very important occupant of sustainable building design and also becoming increasingly popular in both new constructions and also in the retrofit projects. So rise of HCFCs and HFCs. So HCFC, that is hydrofluorocarbons, and HFCs, hydrofluorocarbons, are their synthetic refrigerants and that have been widely used in cooling systems for many years. These have been found to have negative impact on the environment, and the emissions, varies from something around 27 APC C11, which is equivalent of some gases, and they also have an impact on the environment very severely, as they have potent greenhouse gases that contribute to global warming, and their reduction is very much necessary. So, because they play an important role in manufacturing of coolants, their reduction is the very need of power. Now, HCFC and low GWP, that is global warming potential, refrigerants are alternative to our traditional refrigerants that have been found to have negative impacts on the environment, and they do better, particularly with regard to ozone depletion, greenhouse gas emissions. But non-HCFC alternatives, which includes, some of the HFCs which have lower ozone depletion potential, which we call ODP, and but they have high global warming potential. So additionally, the use of passive cooling techniques such as natural ventilation, shading, it can help reduce the need for mechanical cooling, and therefore it will reduce the use of refrigerants altogether in the complete building. So important of this, they reduces the negative impact, environmental impacts which are associated with the traditional refrigerants, which we discussed just now. Those alternatives are very important for meeting global regulations and standards, especially such as Montreal Protocol or legally amendment, etc. And adoption of such non-HCFC or non-GWP refrigerants is an important step towards the sustainability and environmentally friendly cooling and refrigeration systems at present. Cooling agents, we have both here, I'll talk more about modified refrigerants that can be used in equipment, cooling machines that depend on traditional refrigerants. And these are most widely used non-HCFC refrigerants, and they are commonly used as replacement for HCFCs. However, they have a high global warming potential, as I said, and also being phased out in some countries, because of some environmental laws, etc. And see, this is the timeline of different coolants the manufacturers have modified. In the meantime, CFCs are very popular in 90s, which have been phased out, the process of phasing out. Then, HCFCs came in early 2000s, and now we are modifying HFOs. And with modification, their ODP and GWP is also very much decreasing. However, blend of these HFOs, HFCs is being used nowadays by agencies or planners, civil engineers, architects, etc. Though we need a better alternative. So this is some information on the chemical action of HCFCs. So which I'm not going in detail, but just some information, because this is the type of fluorocarbons which have been widely used for different industrial applications. So design of health and comfort. So by incorporating these strategies into the building design, like quality, air quality, thermal comfort, lighting quality. So the indoor environment can be optimized for both health and comfort of the occupants. It can be, nowadays it has become essential to guarantee high standards of occupants' health and comfort in indoor environment. Just to achieve this high level of IEQ, it's very much necessary to consider that the human perception of the indoor environment is affected by 4 basic environmental factors, something like thermal environment, air, acoustics, and light. So here are some of the codes we have, it like energy codes and standards. So energy codes and standards, so regulations and guidelines that establish minimum energy efficiency requirements for the buildings, and these are like aimed to reduce the consumption, energy consumption, promote energy efficiency, and reduce the environmental impact. Actually, we need a lot of awareness on this, and of course, a lot of skill development is required for this industry. Two of the most widely recognized energy codes and standards for buildings are LEED and Energy Star, with the ultimate leadership in energy and environmental design. and wherein the rating systems are developed by the US Green Building Council that provides a framework in designing, constructing, and of course operating the sustainable buildings. And it also considers various factors including energy efficiency, water efficiency, environment quality, indoor quality, and sustainable site development. Then there is another one like Credit Star, so voluntary program which has been developed by this Environmental Protection Agency, which generally focuses on the energy efficiency, and it considers various factors including energy efficiency, performance, durability, ease of use, environmental effect, cost effectiveness, etc. So in India, we had GRHA. So GRIHA has been widely adopted, we know, as a tool for sustainable building design and construction, and is recognized by Ministry of New and Renewable Energy, Government of India, as a national rating system for green buildings. And in this one, Indian National Rating System for Green Buildings and Sustainable Habitats, which has been developed by the Energy and Resource Institute in 2007 with the support of Ministry of New and Renewable Energy, Government of India. It evaluates on different parameters like site selection, water conservation, energy efficiency, use of renewable energy, materials and other resources, indoor air quality, and health innovation. And it encourages the use of passive design strategies also. What is our India's plan to phase out this HCFC? As evident in this presentation so far, HFCs are trending as an alternative to HCFCs, especially the use of refrigerants. To meet this one, like we need to phase out this HCFCs, and HFCs need to be phased down. So ozone depleting substances, which are like based upon this amendment rules, to facilitate phasing out. So two important GWP coolants, that is HCFC 123 or HCFC 22. So Ministry of Environment Forest, has also given some alternatives to various agencies or the manufacturers to phase out this certain GWP coolant, which is on the software. And alternatively, to this, so HCFC 123 is a low GWP HCFC refrigerant, which will be phased out in the country by 2025 as per the ozone depleting substances. So, and HCFC 123 is an energy efficient refrigerant due to its thermodynamic or thermophysical properties. So it is more commonly used room air conditioners, and HCFC 22 is a single component with a higher ODP and GWP than HCFC 123, which is a blended refrigerant that has a lower ODP and GWP, potentially more toxic in nature. So, but HCFC 22 is generally considered to be non-toxic. India's initiative for prioritize this passive cooling. So, these initiatives demonstrate the government's commitment to promoting passive cooling techniques in building design and construction as a part of its efforts to reduce, energy consumption and promote sustainable development in the country. So, Energy Conservation Building Code, ECBC, it is a code that sets minimum energy efficiency standards for commercial buildings in India, which also includes provisions for passive cooling such as natural ventilation, shading, use of reflective materials. National Mission on Sustainable Habitat is a government initiative that aims to promote sustainable habitat through the use of green buildings, renewable energy, and water conservation. So it includes focus on passive cooling techniques in buildings. So green rating for this integrated habitat assessment. So GRIHA is a system rating system. We know that for green buildings in the country, which includes the criteria for passive cooling techniques and smart city mission. Under this mission of government initiative to develop 100 smart cities in India, the mission also focuses on sustainable building design, including the use of passive cooling techniques. And we have Bureau of Energy Efficiency, BEE, is a government agency that promotes energy efficiency in India. It also developed guidelines for energy efficient building design, which includes provision for passive cooling techniques. So let's go through a couple of case studies. So this is a living laboratory on CPT University campus, and it's a home to Center for Advanced Research in Building Science and Energy. This net zero building, energy building, is a fitting example on how the lab for continuous and in-depth energy efficient research can be demonstrated in building itself. And this is a high-tech lab houses the state-of-the-art equipment. You can go to or check their website, and also measures thermal and luminous effects in buildings, and of course its building components as well. So it is a 498 square meter lab building, and it incorporated the following energy efficiency measures. Here are some of these. It has insulated walls and roofs, and there are clear stories and vision, glazing, light shelf on the south side bring in diffuse daylight. And lighting load is limited. The task lighting has been provided. In the natural ventilation mode, the thermal chimney is operated to allow natural kind of draft through the building. So here are some of the highlights. I can say any example. The features of this building is an integration, sensors, and the cooling in this building continuously for monitoring also to perform and its performance based on the comfort levels of the occupants. And in this project, at any point, approximately around 900 high accuracy research grade sensors are operational in the building. And the lamp is like 15% surplus energy fed, 15% surplus energy to the electricity grid, especially in 2015. Very low energy performance, which is EPA of 58, has been seen. The second case study, this is like Horian Craft Limited, is one of the leading garment manufacturing and export houses in India. So this is the facility, and it has in a hot, dry region in Rajasthan, and it's an energy efficient building. And these are some of the highlights of this building. This factory design uses good thermal mass in walls, low lighting load, a very low window to wall ratio, that is 13%, and with adequate shading, it reduces the cooling load to up to 60% in comparison with the normal or the conventional building. And 77% of the building area is entirely conditioned by an operative cooling system. In the office areas, a split system is used due to some space constraints, and the variable everything flow system is also used in the embroidery room, and also equipment has been maintained at very, very low temperature. So this is another case study of a building that has been selected, and 80 passive cooling strategies were applied in this one, like shading device, double glazing, natural ventilation, green roofing, insulation, something evaporative cooling, indirect radiant cooling, light colored coating. So these are all being considered. So in the passive cooling design, it's very important that all the main elements of the building should either block or reject the solar heat gain, and by doing that, try to keep the building cool against the heat in summer especially. In-depth analysis shows that there is a potential for reduction of the cooling load by 9% after you apply these passive cooling strategies. And in the hot, arid climates, most of the energy load is from the mechanical system. So this could be reduced by adding elements to this building by designing such a shading, etc., so which can reduce the energy consumption very much. And this is another case study where the passive cooling techniques has been considered. So it is a two traditional. One is a masonry Chinese shop house, and another one is a timber Malay house in Malaysia. So they use night ventilation techniques in the same houses to understand its effect actually. In terms of this indoor and outdoor temperature relationship, the regression line for the Malaysian case study predicts higher indoor operative temperature than those predicted by the regression line for terrace houses in daylight conditions. So based on the above observation, the potential cooling strategies can be suggested like this: night ventilation, roof ceiling insulation, window wall shading, country yard or forced ventilation, microclimate, underheat island mitigation techniques. So these are some of the references. I also try to use it for this presentation for detailed visit. So with this, I thank you for organizers to give me
We'd like to thank Professor Neelam Satyam for her wonderful presentation. And it's also highlighting to see such buildings already existing. The only thing is we'd like to have many more and to really have an impact on the environment. Now I'd like to invite Shri Ajay Ratanji. He is the Associate Vice President, Corporate Services in Tata Blue Steel Private Limited. So we're going to hear from him regarding sustainability in construction industry. I'm sure he's going to speak upon materials. Mr. Ajay Ratanji, could we hear you?
Thank you, Dr. Kumar. Am I audible?
Yes, you are. And we're
Thank
really sorry we have this internet issue.
No issues. Let me try to struggle to get my presentation on. Let me see if I can get that. Okay. How to do this? Give me a minute. Can you see my presentation, ma'am?
Yes, it's visible now.
Okay. So thank you, Dr. Kumar, and thank you, Dr. Sarup and CIDC team members, as well as the dignitaries. The team since morning, there are a lot of.
Can you make it full screen, sir?
Sorry?
Can you make it full screen?
From my side, it is full screen only. Is it not?
No,
No, sir, it's not in.
Can you help me?
Yeah.
Give me a minute.
Yeah, it's in presentation mode, sir.
So, okay, is it fine, Dr. Kumar? Is it visible to you also? Is it in presentation mode for everyone? Can you see this, Dr. Kumar?
It's in presenter mode, not presentation mode. You have to swap it to presentation mode.
Just help me, Vaishnavi. Okay. How to do that? Just can you help me?
I guess we can continue with it.
Yes. Okay. Apologies for that. Okay, so thank you everyone, and thank you the students and as well as the audience. So I come from, I represent Tata BlueScope Steel Limited. I'll just briefly touch upon what Tata BlueScope Steel is all about. And I will be covering basically sustainability in construction industry, and where we are basically focusing our operations are basically focused to construction industry. And these are contents of my slides. Some of the slides will only be run through just to show that. So basically Tata BlueScope Steel is an equal joint venture between Tata Steel as well as BlueScope Steel Australia. What is Tata Steel in India is BlueScope Steel in Australia. So all this color-coded technology, what you see in steel buildings, be it metro stations or railway stations or industrial sheds. So this technology was invented by BlueScope Steel Australia, and then there was a joint venture between Tata Steel and BlueScope Steel Australia. That's how this technology is there in India. So, and we are present in almost 26 countries, and both the companies are almost 100 years old. and they are known for sustainable solutions. So if we talk about our business verticals, we have got 3 major divisions. One division makes the color-coated coils. The first one, what we say is, almost all the brands are 100-year-old brands, whether we call Zinc-Alume, which are just without color, plain coils. Color bond is the coils having colors. Then we have got building products. And in this, Durashine is a retail product division, which caters to all the retail needs, small industries as well as residential sector. Lizette brand, again, it's almost 150-year-old brand. This caters to project needs, large projects like steel buildings, metro railway stations, or solar structures kind. Then we have got building solutions, small, what you say as easy build structures, which cater to small complete building, especially for farmhouses or cattle sheds kind. So this is not a product presentation. I'm going to talk, as I said, I just wanted to give an introduction. Before I go to the main slide, I just wanted to give the introduction of our company. We are present all across the country, including Sri Lanka. And so sustainability, for me, sustainability actually rests on 3 pillars, 3P, what I say: profit, planet, and people. And in this, definitely planet comes at the top. Rather, I would say people come first, then come planet, and then comes the profit. However, the talk is much around planet, or I would say whatever activities, what we do, which will help us handing over this planet in the same shape or in a better shape to our next generation, is all part of sustainability. So my presentation will be around that only. And we'll also be talking about the environment part. So as I said, it's like 3 Ps. What we say is that you use less resources. As Mahatma Gandhi once said, there's enough for everybody's need, but not for greed. So we need to be very mindful that we need to use less of resources, what are require optimal uses of resources. And whatever we want to use, we need to go for smart solutions and innovative ways. We have been hearing from all the speakers that innovation is the key going forward. And we should try to design, all the designers should design the products for its complete life cycle. We should move away from linear economy to circular economy. That is utilizing the product for the entire life cycle. And lastly, but the most important thing is, how do you end the life of a product? Is it going to be just going to add to the landfill, or is it going to be reused, recycled, or remanufactured? That's the most important thing. And why there's a urgent need for everyone to be very mindful that there's an urgent need to all of us to be contributing in the journey of sustainability, because these are the 2 studies which we are very well known, and all the environmentalists know about this. First one is the 9 planetary boundaries theory by Stockholm University, Resilience Stockholm model, which says that out of 9 planetary boundaries, 6 are already been breached till last year. And some of them are already crossed, they have reached to red zone. That means we have done the irreparable damage to these boundaries. The second one also, the Earth Overshoot Day, is equally, I would say, concerning. What is Earth Overshoot Day? There's an agency which maps. See, there's a capacity of Earth to regenerate the potential. That means there's a limit to which you can pollute a river. There's a limit to which we can add to the landfill. After that, once the limit is breached, then the potency of that particular resource is gone. And ideally, so the limit of Earth, I would say, is that whatever pollution we create is taken care by Earth in the entire 12 months. That means we are reached to the limit. But unfortunately, last year, the Earth Overshoot Day happened in the month of July. That means indirectly what we are trying to say is we are producing waste equivalent to almost 2 times of Earth. We require 1.75 Earths to manage the waste that we are generating. So this is high point of concern. As I said, I'm going to basically talking only about steel because we basically operate in steel industry. So steel is central to circular economy, though it also has got issues. It also has got issues, but the better part is that it's a recyclable product. So it's 100% recyclable, and there are a lot of efforts going on to make it a green steel. Already, a lot of development has happened, and we at Tata BlueScope, we are totally committed to 4R. That is, we reduce the the consumption of resources. We try to reuse each and every product, and we try to also explore the remanufacturing ability of that product and ultimately the recyclability of that. And there's a huge potential in India to increase the usage of steel. You may see that as against per capita consumption of world around 225 kilos, we are at 71, pellet 71. So there's a huge opportunity for us to look at it. The challenges of construction industry, what we say is that the designers, the specifiers or the influencers, they should be very mindful while specifying their products. They should be very much careful whether the product, what they're going to specify, is it a sustainable product or not. And when we say sustainable, it's not only recyclability, it's also, as all of them were talking about, the energy conservation, the water, how does it pollute the nature, how it goes to landfill, or can it be recycled, or can it be used for rainwater harvesting, or can it conserve electricity? Is it compatible with the renewable energy like solar or wind? So these are very important points. Coming to the green credentials, so we heard in the morning also, Griha, this is a very good rating. Green Pro, there are other ratings are Green Pro. We are the first one to get Griha, Green Pro, and EPD in our industry. Not because that we wanted to achieve something. Only thing is we wanted to enhance the I would say standard of the industry by benchmarking ourselves and sort of giving a solution to the specifiers as well as design engineers that these credentials are going to be very, very important. They're going to be very critical in the going future in deciding the choice of material. It's not always the L1 basis. There has to be equal weightage to these kind of credentials as well. So there has to be differentiation in the offering that you're getting. If there are two products and one of them has got green feature, the product is certified by, let's say, Griha or Green Pro or some other reputed agencies. So definitely some criteria has to be there to give that weightage to it. EPD is Environment Product Declaration. Each and every, so it's a life cycle of the entire company and the product cycle. So we have gone ahead with that to map the carbon footprint that we leave. And it is very important in the journey of sustainability so that we correct where we leave more green carbon footprint. Equally concerned is I was talking about people. So on one hand, we have a segment of society which consumes almost 2 times or 3 times the need. And on the other hand, we have got a segment of society which find it very difficult to meet their 2 ends meet. And if we talk about our country, so almost 27% of our population stays below poverty line. And so this is not a very, I would say, hearty situation. And if we talk about workforce, the biggest concern is the skill development. See, construction industry we talk about, it is a very, I would say, it shares a significant portion in the GDP of the country. And in that also, if you see the kind of manpower which is employed, so there are hardly any certified courses which are certified by the government of India, at least at the level of supervisory level or the workforce level. We have institutes, engineering colleges, diploma, ITIs, but if we talk about a site supervisor or a workforce being employed at construction site, you may be having courses on plumbing or electrician, but what about handling construction, or I would say steel construction for that matter? And if you have seen to or you've been to one of the sites of steel construction, be it a metro site, metro railway site, or a steel plant. So steel plants are normally as high as 80 meter, 100 meter high buildings. Just imagine a worker coming straight from his agriculture ground, because he has only one once in a year crop, and he sort of devotes himself to construction sites, deploys himself to construction site without knowing how to handle tool stackers, how to manage the risk at the site, and is deployed at the height. So that's why we come across, if we experience a lot of injuries, fatalities on the construction site, which is highly unorganized, and a lot of regulations are required there, and skilled and certified, I would say, for workforce is the need are there. If you talk about site safety of this construction site, again, this is again just a customary, I would say, customarily only it has been taken care. Rather, I would say, we have also studied. So I'll just share one interesting example. So we hired a professional agency to do the survey to know the situation of construction industry in the country. The agency herself was quite amused, saying that most of the companies hire consultants to know the brand awareness, brand equity, or customer preferences, customer taste. But the agency was also amused that not many companies hire professional, I would say, research agencies to know the needs of the construction workers as well as the industry. And that is where we came to know that most of the workforce, they immediately need some skill development programs, some certification programs, as well as the safety at the construction site, so that they get a very, very safe working environment. Now, lastly, the diversity in the construction site. You will be very much surprised that even though almost 10 million or so of workers are employed in construction industry, but I would say the female workforce is quite less, and that also is at the lower level only. You hardly see the site supervisor or construction manager being a female. And that is where, that is one part, is that we need to create an infrastructure wherein the female workers or the diversity also sort of participates in this other growth journey. We have almost 49% of females in our population. But if you see the corporates also, one of the best corporates also, barring few segments like banking or so, you'll see that most of them are struggling to get the diversity in place. The reason being, we don't have sufficient infrastructure wherein we can push or we can either attract the diversity on the work culture, work space. The challenges what we face in the construction site, basically training and certification, complete and correct PPE. Now, it is not a cost. Many times you'll see if you leave it to a small contractor, he will always treat a correct PPE as a cost. Whereas it is not, it is mandatory need. Lifelines or harnesses, if the worker is working at a height, it is mandatory that he is using all sorts of PPE, the shoes, the goggles, harnesses, and working at height is one of the biggest hazards while working on the construction site. Otherwise, the other hazards also, whether it's electrical hazards or fire hazards or the health-related or medical assistance, these all are defined in different codes of building construction. But whether they're being deployed or not, we have, in the same survey, we came to know that in Singapore, we got a different agency who ensures that all the codes are being properly deployed at the construction site. In India also, I request CIDC also to take this initiative, have a body to ensure that the I would say the norms of building different codes, whether it's a migrant workers code or a building of construction workers code, they are being properly deployed at the construction site. And if we talk about other challenges, the availability of skilled manpower is the biggest challenge in construction industry. The contract workers, mostly they are migrant workers. They migrate from one state to other, leaving behind either their families or they bring their families. And when they bring their family, what happens to their family? Are there women folk working, getting the employment? Are their kids going to schools? Even those who are working and are they migrated, are they getting good housing or accommodation? So these are the related, I would say, these are very important part of sustainability. Not only planets, the people also play a very important role when you talk about the sustainability. Training costs. Now, who bears the cost of training? If I talk about CIDC, so I'm very thankful to Dr. Sarup and the team of CIDC, where they gave us opportunity to curate a very, I would say, interesting course with them, wherein they have adopted our content in their regular 3-month course, wherein after 3 months of going through that course, the construction workers also get that certification, which is accepted by almost 180 government departments. And we are very thankful CIDC to adopt that course. And we are also sort of encouraging a lot of people who want to make career in the construction industry to go for these courses and have that certificate in their hand, so that one, they are not exploited in the field. Secondly, they know how to manage risk as well as, and how do they improve the productivity also. It is not only good for the workers, but it is also equally important and good for the construction contractors, I would say. They also improve the productivity. As I say, already mentioned about D&I, diversity always bring in a lot of innovativeness and a lot of new ideas. They come, they also improve the working standard of the workforce. What may be taken granted for men workforce sometimes are improved when the moment the women workforce also join the hands. So these are some of the challenges why D&I or the diversity is taking time in our country to be adopted by the construction industry. Some of the initiatives that in Tata BlueScope Steel we have done. So as I said that we have initiated one Jagriti program in our company, and where we celebrate all the important days, be it Earth Day or health, the whole Sight Day, World Sight Day or Cancer Day, to bring awareness around health, safety, environment. And all our plants, we have switched over to renewable energy, and be it our door farming plant in Bhiwadi or Jamshedpur plant, we use a lot of solar energy. And one thing is, almost all our products are compatible with solar installation. That means solar panel can straight away be put on our products. So this was another thing I wanted to say. We have switched over to mist kind of and sensor-based taps, which reduces the consumption of water by 50%. We give a lot of focus on tree plantation, increasing green cover. And as I said, we are the first one in our industry to get EPD certification. We were first one to get GRIHA certificate. We were first one to get IGBC Green Pro certificate. And this is again very interesting. We in our product, one is we use only good pigments which can be used, one, for recycling and also for rainwater harvesting. Secondly, we also have a Thermotech technology which reduces the temperature of the room inside because of higher solar reflectivity to the extent of 5 to 6%. So this is again unique feature. We have heard one of the speakers talking about this, the higher SRI values. So it lowers down the temperature by 6 degrees. Our solar journey. So when we started solar journey, we are also involved in creating structure for solar generating farms. And in the year 2010, when we started the journey, so we designed the structure also. That time we took 130. We used to use 130 tons of steel for a solar farm of 1 megawatt. But now, using innovation and different and sustainable products, it has come down to 27 tons in 2019. Just see how much steel we have reduced. There's a great innovation here. Some of the pictures of solar farms where we have contributed. Safety, as I said, is very core to our heart. We believe in zero harm to environment, zero harm to people, zero harm to plants, and we feel that all the injuries can be avoided if all of us, one, those who are at the I would say at the authority to implement the policies, they can implement the safety policies. We are also very confident all the injuries can be prevented if all of us start following the safety norms, re-roofing some of the projects we have done. So some of the pictures that we have done. So steel basically is known for the strength, but as I was saying, BlueScope and Tata BlueScope Steel basically have added beauty to steel also. You can see. Kavach is again a very unique program, which an initiative we started in collaboration with CIDC. Thankful to CIDC, where we give on-site training, crash courses to the construction workers certification program for semi-skilled workmanship, and which got widely covered by media as well as a lot of industry. So some of the pictures, the workers were so much emotional, saying for the first time in my life, this guy was saying he got a certificate from Government of India. Quite emotional moment. Some of the projects that we have done, most all steel, made out of steel, very sustainable products. Some of the buildings which can be used by using steel, and they're all green buildings. Some of the, again, project side pictures. You can see this is the admin building of BASF. Doesn't look like made out of steel, but it is made out of steel profiles only. Beautiful building. So leaving the group with the thoughts, the challenges of the industry, construction industry, that all the specifier designers should go for sustainable building products. They should focus and give weightage to the green credentials of the product specifications. Go for skilled workforce, as CIDC is also working with the government agencies to make it mandatory to have almost in the, I think in CPWD, they made a norm that 40% of the workforce have to have certification from agencies like ITI or CIDC. And safety, site safety, construction safety is equally important. The way it is important to have choose green products, equally important is give weightage to the site safety. And lastly, diversity. It is our responsibility to enhance the work quality of life of workforce as well as the people, and bring in diversity on the in the working area. Thank you, everyone. Thank you. Over to you, Doctor.
Thank you, Dr. Ajayratan. It's really a pleasure to listen to you, and especially now the focus on cyclic construction for sustainability. We do feel strongly for that. And yes, we all feel strongly for women workers. We hope the people who are listening, they also think about utilizing and creating an environment where they can be comfortable and be productive to the system. Thank you. Thanks a lot. Now we know another material that all people were talking about, designing and everything. But now we know there's a material that can be used much more than it is at present being used. Thank you. Thank you once again. And now I would like to have the presentation of Professor Jagdish Godiyal. Professor Jagdish Godiyal is a professor of civil engineering and Deputy Dean Academic Research, Presidency University, Bengaluru, Karnataka. So can we have his presentation, please? Thank you.
Yeah, I'm going to talk on sustainable and eco-friendly concrete hollow blocks manufactured using construction and demolition waste, complying to 3 dimensions for sustainability. Myself, Professor Jagdish Godiyal, Professor in Engineering Department, Presidency University, Bengaluru. And then this workshop is organized by CIDC and ANZ, Ministry of Environment, Forest and Climate Change. In my presentation, this is brief about me, who I am, about where I'm working, my qualifications. I'll just hurriedly go through this. You can look into the qualifications, and work experience, and then the projects I got from different organizations, and then I have executive patents and then certifications from IITs and some foreign universities. Then presently 6 PhD scholars are working under me under different topics for 40 publications in national interest. Okay, my presentation flow will be, I'll talk, give a brief introduction on construction, and he is going to help us in protecting the environment and also the complying to the sustainable development goals of UN, and also the 3 dimensions of sustainability. So introduction, methodology adopted, and material characterization and inferences. The material used here, it is a recycled concrete aggregates and the coal ash. We have characterized them and then accordingly we have prepared a risk design. Okay, then the case studies which we have done in our university. I'm going to discuss on that. And then the summarizing the talk. Okay, first is environment. If you look into the environmental framework, the environment is nothing but a physical environment surrounding conditions and elements with which the living things interact with the physical, both chemical and biological attributes, and we call them as biotic and abiotic factors. Okay, then enviro is nothing but to surround us and enclose. Okay, enviro means the idea that the micro scale to largest to global scale. So now this environment is under pressure. Okay, because of the population pressure and then resources exploitation pressure, especially in the construction industry, we require a lot of construction material, especially cement, concrete, aggregates, and all those things. So from that angle, so there is a lot of pressure on the environment. This is how we can reduce this pressure by recycling the material from the construction demolition waste and also the industrial waste, how we can utilize them so that we can reduce the pressure on the environment by not taking the natural resources. Okay, that is what I'm going to explain. And pressures resulting from human activities will bring about the changes in the state of the environment. Okay. Then before going to that, let us talk about something on development and sustainable development. The basic difference: development is nothing but it is aims at rising the quality of life of only present generation. But whereas if you look into sustainable development, it is considering both. Both it is will be having sustainable aims at rising the quality of life of both present as well as the future generation. That is what is required. We have to go for a sustainable development. Sustainable development given by the various commission definitions and UN and all those things. That is the carrying capacity of the supporting ecosystem. As I mentioned, environment has got a tremendous capacity, but it's not an infinite capacity, it's a finite capacity. So that is the reason we need to look into its carrying capacity. Accordingly, the resources exploration for our developmental work as well as the discharges, what the waste products we are discharging into the environment has to be balanced and has to be taken care. Then only we can have a sustainable development. Then again, brief about the 3-dimensional sustainability. That is, we talk about environment, economy, and social. That in terms of technically, we can talk about ecocentric concerns, where natural resources and ecological capacity we need to understand. Then technocentric concerns, we need to develop a new technology, that is CDM. There is a new technology as well as we have to think about the socio-economic concerns, human capital and social expectations, and what is the impact of this climate change or impact of deterioration of the environment or depletion of ozone layer is happening on the social life of the people and how we can improve on that. That is what we need to look into. So if you look into in our case, we are taking 3 SDGs, Sustainable Development Goals, responsible consumption and production. That is what we in our project we are using more recycled aggregates as compared to natural aggregates. So that is what responsible consumption and production. Then climate change, that definitely we are getting rid of the carbon emissions here by using recycled aggregates. Thereby we are reducing the carbon emissions and helping in the climate action. And also the conservation of natural resources. As I mentioned, instead of natural aggregates, we are going to use the recycled aggregates. So for our study, we have adopted the methodology like this: recycled concrete hollow blocks we have prepared with the optimum percentage of replacement of recycled concrete aggregates and eco ash, and complying to the higher standards given here. And then second objective is monitoring the comfort index. That means if we construct the buildings with these hollow blocks manufactured out of RCA, then ultimately how it will be the comfortness to the inhabitants of that particular dwelling. That's what we have actually done a case study, and we have got some good result. That's what I wanted to share with you. And this is my brief flow about how exactly we have done in our project. There is materials used. We have taken these two prominent materials. Both are, one is a construction demolition waste. That is recycled coarse aggregate, another one is a coal ash from the industry. It is again waste product there. Then we refer to this code, and we have manufactured both circular concrete hollow blocks as well as rectangular concrete hollow blocks. That we have constructed the blocks using these that I'm going to show in subsequent slides. Then we are going to have a real-time monitoring of temperature for a comfort index, where with the sensors and all those things as per the we are monitoring as per the IGBC as well as the WHO. Then even we are considering the ASTM codes also and IS codes. Then inventory of carbon energy also we have worked out. Then ultimately we are measuring these are the test compression strength of the blocks and all those things. Here both they have to have both the stability point of view as well as the comfort point of view. We are considering the blocks in the mixed design of the block. It has to have a stability, means it has to have a durability in the sense strength. It has to stand all the its own load in addition to that the other destabilizing loads and everything that has to stand. And also it has to provide a comfort environment to the inhabitants of the place. Then the inventory of the carbon, that is greenhouse gas emission and economic index, that we have taken. That means how by using the recycled concrete aggregates, how much carbon emissions we are reducing. That we have calculated for Bangalore city from different locations. We are taking the recycled aggregates, and then that is the direct tripping cost also we have measured. So ultimately, all these things are complying to the what is known as the three-dimensional sustainability, social, economic, and environmental. Okay, then if you look into the recycled concrete aggregates, this is how we have prepared the blocks. This is the blocks we have prepared, how we have prepared the blocks. Okay, sources, thermal power plant, electric, actually it's a coal ash, fly ash, and then it is recycled construction demolition waste recycled plant. We have got the recycled concrete aggregates, then the cement and M-sand, the fine recycled fine aggregate. Then okay, natural coarse aggregates, and then we have these different modes. There is a circular hollow blocks, then rectangular hollow blocks. These two we have prepared. Then for a different mixes, we have mix 1, mix 2, mix 3. If I explain mix 1, it is here coal ash is 0% and recycled concrete aggregate is 0%, means it is 100% natural aggregates. And then definitely this is the what the compression strength we have observed when we have conducted the test. And when we change the proportions, coal ash and recycle in this way, then ultimately if you come to the mix 9, where 45% coal ash and means only 55% the cement, and RC is a recycled coarse recycled concrete fine aggregates, and here is a recycled concrete coarse aggregates. So then in this case, see the difference here. It is in case of 48 reduction. We talk about the reduction, and here we talk about the reduction in the concrete compression strength. Okay, again to ascertain the whether they are durable and also the required compressive strength is attained, we have conducted these slump and water and water absorption tests for various mix hollow blocks, and definitely they are complying to the further IS codes what recommended. Then comparison of application of different composite concrete hollow blocks, if we say of different mixes, then if you look into the IS 2185, 205 and ASTM, that means definitely the mix 6 or 7, almost all they are for a non-loading, and then up to load bearing it will be up to mix 4. Okay, for mix 4 it will be there. For if you want to have a concrete blocks for road, or if you want to have a partition walls, then definitely we can even use the higher mix with more recycled fine aggregates and coarse aggregates. That is what we have got from our tests. Okay. Then we have done the analysis, material characterization, and then also we try to correlate that with the attainment of the strength and also the thermal conductivity. These two are required for our study. First one is for the durability, the strength, compressive strength is required, and thermal conductivity for the comfortness index what we are developing from that angle. Thermal conductivity is one of the parameters here. That and when we have done the characterization of the coal ash as well as that of the recycled aggregates as well as natural aggregates. Some analysis we have done. Then definitely in the recycled coarse aggregate, there is attached mortar and some cracks are observed. And then these are all the different compositions, mineral compositions, what we have observed, and then definitely we have taken into consideration all these things in designing the mixed design to meet our two requirements. One is the strength, another one is the conductivity of heat and other parameters. Okay. Then again, if you look into the material characterization inferences, what we got, the bottom ash, that is a coal ash, what we have used is unburned carbon, and it has more porous vesicular structure, and consequently it's crushed more easily under the compacting and loading. That means that is why we cannot use more and more. If you don't use more and more, then we may not get the requisite compressive strength that is required as per the IS codes. Okay, then test results of thermal conductivity. Coal ash showed lower thermal conductivity, and this is what is required for us. Moisture content and ambient temperature, all of it thermal conductivity. Then again, a coal ash additive mixes have potential to be used in the thermally efficient construction, where we are for the literature and literature show that, and also when we analyze, we infer our results. We infer our result definitely that is also matching with what is available in the literature. Okay. Then another case is when the potassium content is low, it can cause the decrease in the workability, plasticity, and the cohesion of the concrete. That also by the analysis of this coal recycled concrete aggregate as well as the coal ash, you know that. Then effect of recycled aggregate on K concrete reduced from 1.20 at per meter Kelvin as composition of natural aggregate reduced from 100 to this is also taken into consideration in the mixed design. Then mainly the thermal conductivity difference in mortar samples is in saturated condition and dry condition is measured, and the thermal conductivity of 18 and 32% is decreased relative to conventional and 100% recycled fine aggregate mortars. This is what we have inferred, and it is matching with the available literature. Then we have done the environmental impact assessment of the recycled concrete aggregate using this equation, and then here we can see the mixed pile. So the mixed pile, the concrete and the emissions of the mixed pile. So in this case, so that means that there is a considerable reduction in the cement, and definitely we are using the coal ash replacement for the cement, and then also the fine aggregates and the coarse aggregate. Definitely it's going to have a reduction in the embodied carbon efficiency. That's even up to mixed pile, whatever I explained in the previous slides. The mixed pile will be giving both meeting or both strength point of view as well as the comfort point of view. Then cost evaluation of recycled concrete hollow blocks under the different scenarios we have also done at the second study. Whether because we need to meet the that is the economy as one of the key lines of sustainability. Then if you look into the the model 3 and model 4. Model 3 and model 4 are recycled concrete, rectangular concrete hollow blocks, and then 4th is rectangular circular concrete hollow blocks. Okay, that is in this case. So that is in that case, so what we have done here, then definitely it is going to have a more less cost compared to that. Then under different scenarios, the scenarios are different here. The direct cost of the material, including transportation, additional cost of RCA, and additional cost of RCA. That means if the site of demolition and the recycling plant is very nearer to your place of construction, definitely the transportation cost is going to be reduced. That is how exactly we have taken into consideration. We have taken this study from in our locality, and then we have worked out, and definitely when we are using the recycled concrete hollow blocks, then this is the cost. Otherwise, it will be 7,518, and whereas it's come to 5,050. It will be very, very less compared to the natural aggregates. Then again, for our second parameter, that is a comfort index, we have built the 3 houses like this, 3 models. So one using the recycled concrete, recycled concrete hollow, circular hollow blocks. Another is the recycled concrete, circular blocks. These are the two we have used, and one is it is a solid block. Okay, solid blocks is made up of natural aggregates. Then we are using the sensors. We have measured. That means 1 year we have kept it inside the building, and now this year we have taken it out and we have kept it outside, and then we are measuring and we are monitoring the what is the temperature differences. Here we are getting again these cavities are also filled with the agriculture waste, coconut fibers as well as bagasse. That is what we are experimenting, and definitely results are very much encouraging on that angle. If you look into the result, morning 6 a.m. to 12 p.m., then the model 1, the overall morning temperature monitoring model 1, that is having the circular hollow blocks, and then with the coconut fibers as the pillar material. Then we are having in the afternoon 12 to 6 p.m. The highest afternoon slot temperature recorded in this week is 38 degrees in model 2, that is conventional solid blocks. Whereas if you look into that, there is a 5 degrees Celsius and 3 degrees of experience in the model 3 and model 1 with respect to the model 1. Then 25% is considered to be first in the means. That is why in the afternoon 12 to 6 p.m. if you look into, then these circular hollow blocks with the pillar material and rectangular hollow blocks with the pillar material, they have shown the less temperature inside where it leads to the comfort levels. So these are the another set of results in the night 6 p.m. to 6 a.m. and then definitely in the relative humidity from 6 p.m. to 10 p.m. is almost half the times lesser than the remaining time in the evening slot due to the rapid drop down in the temperature and chillness in the midnight. Okay, a similar range is here also 24 to 25 degrees Celsius. These are the other set of graphs we're having. Then if you summarize, then looking at the study, what we have done, we have manufactured the concrete blocks using recycled concrete aggregates as well as the coal ash in a different proportion, and in that different proportion, we have got, if we are going to use the coal ash 35% and recycled concrete aggregate 74%, it can take load bearing greater than 13 MPa as per the ASTM code as well as greater than 5 MPa as per the standard codes. Okay, so then we have got one conventional rectangular concrete hollow blocks and circular concrete hollow blocks, emits 1.42 kg, and that is concrete circular concrete hollow blocks 1.67 kg greenhouse gases. Wherein one, if you are manufacturing these blocks with coal ash 45% and recycled concrete fine aggregate 94%, then in that case, that particular blocks using this proportion, that is rectangular concrete hollow blocks and circular concrete hollow blocks, emits 0.8. See the reduction 1.426 to that is 0.8, and then here 0.8 kg greenhouse. This is how actually 40% reduction in the environmental impact what we have observed as per our study data. So then the cost of one conventional rectangular concrete hollow blocks and the circular concrete hollow block is 58 and 42 Indian rupees. So then wherein this, if you are going to use replacing cement with CA45 and RCFA90, then ultimately they are working out to 23.8 Indian rupees respectively. That is what was study concluded. Then with respect to our second parameter, that is the comfortness or thermal comfort inside the building. Connectivity between coal ash and cement is due to their different physical and chemical properties. What we have done, the characterization we known from that end. Coal bottom ash has a lower thermal conductivity due to its sensibility of material, porous structure and low density, and while cement has the higher thermal. That means more coal ash we are going to use, but keeping the other parameter, that is the durability or strength, that also we have considered. That is we have come to a optimum, that is a CA35 RCA about 60%, 30, 40, 50%. That what we have got in our results. Okay. Again, if you look into our second parameter, that is a thermal comfort. Morning 6, that 3 models what we have analyzed, 6 a.m. to 12 p.m. Model 1 with the coconut fibers as a pillar material, and then coconut fibers as a pillar material, then circular concrete hollow blocks is experiencing the higher temperature and lower humidity compared to the 2 models for a duration of 1.5 hours post in 30 a.m. That is what the temperature difference getting drastic up to 10 degrees Celsius. That what we have noticed when we kept all the 3 models outside. that is open in the open atmosphere. Okay, in the afternoon time, the temperature up to 5 degrees Celsius and 3 degrees Celsius lower is experienced in model 3 and model 1 respectively. With respect to model 1, humidity level in this plot appears to fall 30%, which is considered to be purged, which means of too much heat and not enough heat. Okay, that is outside temperature. Okay, this is what, and then actually, I would like to thank one of my PhD research scholar, Ms. Darshini S. Sekar, for carrying out this work as a part of our doctoral study. Then also I am thanking my management authorities of Presidency University, Bengaluru, for a seed grant project fund to carry out this work. Okay, then I have developed an equation called Jacobi equation of sustainability, where the S equal to EC minus RRC minus WAC, where S is sustainability, that should be 1. How it will be 1? Environmental capacity, as I know, in starting of my initial presentation, I mentioned about environment as what is, but not an infinite capacity, it has got a finite capacity. It has got a known capacity. That means the rate of resources consumption. That is, again, the resources are also limited. They are not infinite. Then the rate at which we are using those resources are exorbitantly high. That is what rate of resource consumption we have to bring down. Ultimately, I'm talking about natural resources. So instead of that, we have to use the recycled material. That's what we have demonstrated in our study, using recycled concrete aggregates as well as the coal ash in that way. And then waste assimilation capacity. When you are discharging the industrial waste and all these waste, again, they are going to have a burden on the environment. Again, that assimilating capacity is also limited, not it is finite, infinite, it is finite. That is why if you are able to stop that, you are able to reduce that discharge on the Earth's surface, then definitely it's going to help us in attaining the sustainability. Okay, then automatically we see if we are within the environmental capacity, rate of resource consumption as well as the waste assimilation, then ultimately we are going to look at the sustainability. And another one message I wanted to give is, as per the American Society of Civil Engineers, as being a civil engineers or any engineers, we have to imbibe and inculcate these two principles in whatever the work we are going to undertake. Principle 1 says do the right project, and once you undertake that right project and do it right, do the project right. That is principle 2. So if we are able to follow this, then definitely we are moving towards the sustainable development goals, complying to sustainable development goals as well as sustainable development from that perspective. So with this, we look into this sustainable development goals, 17 they are there, and also thank you one and all for your kind attention. Any questions there? Then these are all my correspondence. You can contact me if you need anything more regarding this work, what we have done. I'm happy to say. Thank you one and all. Thank you.
Thank you, Dr. Jagdish Ghodiyal. It was a very interesting presentation and some very good ideas that should be implemented in the construction site. So since we don't have time for question and answers, we would like to receive all your questions so that we can share it with the experts and then respond to the questions. Now for the last presentation of the day, we have the presentation by Dr. Niranjan Swarup, who is the Director General, Indian Society for Construction for Trenchless Technology, and he is an Honorary Director of Construction Industry Development Council in Higher Education. He is going to present his remarks on the project report that was submitted to the Ministry of Environment and Climate Change. Can we have the presentation, please? Thank you.
Good afternoon. My name is Dr. Niranjan Swarup, and I worked on developing the ozone cell report, and we are going to take it forward by having the future plans. In the report, we have developed the good management practices for introducing passive cooling designs and promoting the use of non-HCFC and low GWP alternative, that is non-hydrofluorocarbons, low global warming potential alternatives in building construction industry. And as you have been participating since morning, this is the online conference being held today on 21st March. I am Dr. Niranjan Swarup, Director of Higher Education, Construction Industry Development Council. This presentation is structured into 5 parts. That is introduction, available status of the available skills, survey outcomes and recommendations, salient features of program implementation plan, and finally the concluding remarks. I will introduce in the tag concept and the related activity which we perform. All the things require a specific type of skills, and we will discuss the status of available skills in the nation in the building construction industry. Then our survey outcomes and recommendations, that what has to be done. Based on that, we have prepared a program implementation plan, which is under consideration of the Ministry of Environment and Climate Control. So we will be discussing the salient features of that PIP, and then finally the concluding remarks that I want to present to you. Ozone Cell is implementing the stage 2 of hydrochlorofluorocarbons HCFC's phase out management plan, HPMP stage 2, under which we are trying to remove or rather replace the global the ozone depleting materials from our usage. And Ozone Cell, MOEFCC and UNEP decided to implement the activities related to building sector in association with CIDC. In HPMP, there have been actions in stage 1 and partly in stage 2. In the actions till date have been to identify the material or the items which are depleting or which are basically damaging the ozone layer, finding the alternatives, and finding the users and applicators. That is what the actions have been done. Then it was discovered, or it was found, that building construction industry is one of the major agents which can help reducing the application of these chemicals or these materials in the nation, and that's where we can assist the our agreement, or rather the conditions set forward in the Montreal Protocol that we signed for the protection of ozone layer. Under this MOA, we have entered into a memorandum of understanding with the Ozone Cell, and under this MOA, Ozone Cell MOE of 90 with CIDC is taking major initiatives for promoting the good management practices to sensitize both construction community as well as the users towards the benefit of energy efficient buildings by introducing passive cooling designs to reduce the operational cost, improve health and comfort, and promote the use of non-HCFC and low global warming protocol, the potential alternatives, and thereby protect the ozone layer. So the broad objective in the implementation of the activities related to building sector comprises of HPMP stage 2 under the MOA were aimed at the following: to sensitize both the construction community as well as the users towards benefits of energy efficient buildings, organization of consultation and awareness workshops, secondary research, literature review, landscaping of the existing policy, trends, development of the methodology, and implementation. The primary concept, or rather the primary term of having the passive cooling, is basically to reduce the consumption of energy, which in turn somewhere helps in raising the temperature or raising materials which can damage the ozone layer as well. So it starts from there. If we construct our buildings in a way that they get naturally cold, so active cooling energy expenses are reduced. We can save the expense of energy in those activities, and based on that, we can have a better movement or better efforts towards protecting the ozone layer. Now, we did this study, we did the evaluation, and based on our evaluation, survey and everything, we prepared a study report, which was released on 16 September 2022 during the 20th World Ozone Day by the Honorable Chief Minister of Maharashtra, by the Honorable Environment Minister and Deputy Minister. They released this report, and the report copy of the report can be seen on this link, which is Ozone Cells website or Ministry's website. We have charted the course of action for the building construction industry, which we will be discussing in this particular presentation. Now, first of all, we need to understand what are the level of the skills of existing manpower engaged in building construction activities in respect of passive cooling concept. We do teach, train, and kind of put people towards the operational on-job trainings for construction activities. We have engineers, we have supervisors, we have construction workers, but then their exposure towards passive cooling concepts or using the non-GWP or non-global warming potential materials. You have to see what is that, the level of exposure. And this was the first starting step which we conducted to evaluate the situation. On our survey, what we discovered was that the level of knowledge, which was, say, if there are 100 things to know, from 0 to 10 things were naturally known to majority of the people. 67% of the people knew about the basic things which were needed for passive cooling or all those things. But then the remaining 90% things were not known. As we go higher and higher, the numbers of the knowledge level came down, and there were nobody having actual exposure of the 100% knowledge base. So we need basically to cultivate the knowledge base so that the people could start implementing those efforts. Say, for an example, if I construct a building, and while making the building, my facades are something like absorbing heat from the in the summers. So in order to cool my building, I would be spending more energy by way of air conditioning or by way of air circulation or whatever. And that would require substantial amount of energy. And where from do I get that energy? I get that energy from my fossil fuel power plants. I may get that energy from my solar or the wind farms, but there are limitations in my non-conventional energy. So basically, I end up spending my fossil fuel sources to cool my building. And to address that, we need to, like the nation decided to went for India Cooling Action Plan, ICAP. We need to get that implemented so that the extent of energy spent has to be the least. And that is what is one of the primary aims of this initiative, where we want our building construction people or building construction industry constituents to have the proper exposure towards usage of methods, methodologies by which the buildings are naturally cooled. And if they are naturally cooled, obviously I will not spend more energy into cooling them. And obviously there will be an extent of reduced consumption of fossil fuel or other things. So based on that, we did this survey. We defined the outcome of survey, or rather we found the outcome of survey and evaluated the information on the sector present status in respect to passive cooling concepts. We evaluated the future possible growths of the sector, skilling and certification needs with respect to ODS phase out, that is ozone depleting substance phase out, energy efficiency and energy and alternative refrigerants, occupational safety, access to finance and social security schemes, which is very, very important because we are trying to bring in systems where change in the attitude is required, and there will be very less people actually ready to finance this particular operation. So we identified more than ways by which we could provide access to the finance and social security to stakeholders who are applying or going for passive cooling and using the non-ODS material. And then we came up with the recommendation for the sectors. The issues what we identified in our entire activity came up like absence of rules and specifications for passive cooling with the urban local bodies, the urban local bodies designs, requirements. I mean, I would not say that everywhere, but then it's basically not attuned to the maximum benefits from the natural settings can be attained. We could not find a standardized operating procedure where those things have been taken care of. So that basically is the primary absence of rules and specifications. Then comes low sensitization level of passive cooling and non-SCFC and low global warming potential alternatives. People would construct their structure, install sub-sensors which would look beautiful, which would make their building appear very expensive. But then, whether they are really supporting non-HFC systems, global warming, like passive cooling, or have low global warming alternatives, was not there. And most of the locations, most of the times, what we found was that the sensitization was too low. Poor awareness about the various code provisions. In India, the Indian Building Code, National Building Code, NBC, has been released by Bureau of Indian Standards. Now, NBC comprises of different codes, and they have been compiled in one volume. Not rather one volume, but actually in two volumes with voluminous substance. But then the engineers are supposed to be applying that. The sensitization level about that NBC, the latest edition of NBC, was pretty low. And what was discovered that we need to sensitize people and let them apply that. Because if we go in for application of such codes, a substantial part of my ICAP, that is India Cooling Action Plan, would also have been addressed. Then comes high skill gap in the executing engineers. The executing engineers and supervisors, they would be having a very, very different kind of skill levels. They would have better knowledge about the commercial aspects of the construction. But the moment it comes to the passive cooling and related activities, it was discovered that the skill gaps were too high. Less coverage of concept in the professional curriculum. We also evaluated the basic curriculum being offered by the engineering institutions or technical ITIs, the technical institutes, or the vocational training centers. And what we discovered was that these concepts are not majorly covered in the contents being delivered. There was a low strength of faculty members having adequate knowledge base on the subject matter. Obviously, the people who are teaching all these concepts in these institutions also need the proper exposure, because you're teaching a boy to become a graduate, you teach him further, he becomes a master, you teach him further, he becomes a PhD, and he is very good to go as a professor. But then there are very, very limited chances of his exposure towards passive cooling concepts, the non-ODS and SCFC materials. So theoretically, he may be exposed, but actually how it is being done, where it is being done, and what are the benefits are actually not known. Then comes absence or lesser availability of training infrastructure, equipment, and another parameter. This is another difficulty that was discovered during the evaluation. Low finance availability for upskilling of the working professionals, tradesmen, vocational artists, etc. I would just like to point out that the percentage of attrition in construction industry should be about maybe 5%, 10%. So that basically means that every year there would be 10% of the constituents, whether they're engineers, they are supervisors, they are trained workers, or they are unskilled workers. A limited number of people would go out of the industry on account of getting retired, on account of physical disability, or on account of many more reasons. But and it's not bad, but actually what happens is the balance number of people is substantially high and they are already working. Now, if I want my whole industry to work on passive cooling systems, to work on materials which are non-ODS or which are low GWP, global warming, potential material, we need to skill my people who are working in the industry, and those people are actually working on their own, or rather they are employees. Who would finance their education? Because this education is something for which some investment has to be made. And obviously, the finances are not available as per the current practice. So we discovered that. Finally, absence of procurement conditions, not finally, but then another point is absence of procurement conditions, specifications with major infrastructure owning agencies. Organizations which are implementing projects need to have proper exposure towards these requirements and should have the procurement processes by which they can define what is to be purchased and what is to be installed and how it is to be installed. These things are defined in the procurement processes, that is contract conditions, special conditions of contract, or maybe the general conditions of contract. There also these aspects need to be looked into. So what would you do? We came up with the recommendations, that is implementations of the rules and regulations at municipal bodies, enhancing the awareness of core provisions in the stakeholders, high skill gap within the executing individuals need to be reduced. Less coverage of concepts in the professional curriculum has to be addressed, and more coverage has to be given. Low strength of faculty members having adequate knowledge base of the subject matter has to be again addressed, and we need more faculty members having adequate knowledge base. So obviously, prepare people both for the professional curriculum as well as for the faculty members. Absence or lesser availability of training infrastructure, equipment, and other related parameters. So here we need to have proper exposure, proper availability of such training equipment. So obviously, the institutions either have to own the infrastructure or have to have partnerships, maybe academia, industry relationship, where these things can be addressed. Unless until this is done, the boys and girls who are being trained would not be exposed to those things. Low finance availability for upskilling of working professionals, tradesmen and vocational artisans, etc., have to be addressed by few processes or systems that we have identified. Absence of procurement condition and specifications, major infrastructure agencies have to be addressed by revising the contract conditions, their specifications and all. And these are the basic recommendations that have been worked out. Now, coming back to the business plan that we have prepared, and to begin with that business plan, the first step is to identify or define the HPMP phase 2 objective for construction industry. HPMP phase 2 encompasses all type of industries, from manufacturing to construction to power generation and all. The objectives are like HPMP stage 2 objectives related to construction industry are enhancing the sensitization of passive cooling concept to the building construction industry. That's first. Enhancing sensitization of non-HCFC and low GWP alternatives to the building construction industry. Promoting application of passive cooling, non-HCFC, low GWP alternatives in building construction industry through strategies for replacement of conventional processes and alternatives. Enhancing sensitization of India Cooling Action Plan, ICA, in building construction industry, enhancing sensitization of energy conservation building code, ECBC in building construction industry, promoting concepts of managing consolidated energy consumption for the entire building life cycle, optimized through the usage of green building concepts, passive cooling, non-SCFC and low GWP alternatives. So primary objective of our actions is structured into these 6 components for building construction. If we are able to do this, we will be able to bring in the inputs, or basically the recommendations which have been developed on HPMP stage 2, where we have identified various refrigerant materials which need to be replaced in the air conditioning and refrigeration industry. We have identified different kind of insulation materials that have low global warming potential and low impact on ozone layer. All those things have already been identified up till we started, the construction industry started looking at, or CIDC started creating the report. Now, my business is to get all those into construction industry so that the benefits can be maximized and we can have the best possible assistance to the nation by way of usage of these things, so that our energy costs are low and we are able to protect the ozone layer. Although it's very heartening to mention here that the ozone layer is also growing very fast, because most of the nations who have agreed to a Montreal Protocol have been working on it, and the ozone layer is getting replenished. Losses of ozone layer and depletion are very well known, because if they are there, obviously the temperatures, sicknesses, many things or many ill things could happen. The better is the faster we can replace it. And that is where we need all of you to work with us, so that we can come up with a protected nation and a healthy nation. What we decided was, we created 3 kind of organs. One is National Project Implementation Framework, National Project Implementation Unit. Then we have the project then comes Regional Project Implementation Units, that is RPIUs, and then they would be guided by the expert working groups, because all these things would not have a complete control or complete knowledge base available for everybody. So we start with an expert working group which advises everybody, and that advices reach the Central Project Implementation Unit. Central Project Implementation Unit transfers those recommendations to RPIUs, and RPIUs implement them. They also come up with the difficulties and transfer that to CPIU, and CPIU in turn provides that to EWGs, that is expert working groups, and the expert working groups come up with the solutions to such kind of challenges. So this is the basic National Project Implementation Framework linked to building construction industry. Owing to it being one of the, like the second largest employer of manpower, this is a major initiative or major need of initiative to kind of protect the environment. NPIF is to be managed by the CIDC Project Implementation Secretariat, CPIS, based at CIDC head office, reporting to the ozone cell. All PIUs to be manned and operated by CIDC under the guidance of EWGs and ozone cell MOEFCs. And the CPIU is to be based at New Delhi, as I indicated. The regional project implementation units to be established in select locations, spread across the nation to assist the central PIU. The number of such units to be enhanced progressively as the things of progress, and more locations start coming up with this needs and coming up implementing it properly. Now we identified the terms of references for CPIS, the PIUs and EWGs. My intent to tell you all this is to let you know the mechanism by which we would like to, or we would be implementing the recommendations and basically seeking your indulgence in all these things so that we can work further. So let's look at the term of reference as we have proposed. The CPIU does have the following terms, that is, general management activities linked to the program implementation requirement, coordination with different components of NPIF, that is, National Program Implementation Framework components, development and implementation of information dissemination services systems, so that the things are informed uniformly all across the nation, development and implementation of reporting systems, financial management and reporting of operations. So it's a kind of the core center where the things are being supported. PIU would be promoting the good practices through education, sensitization, skilling, and training. PIU would be working for letting the stakeholders trained and exposed and getting the workers or getting the operators knowledge base enhanced so that the maximum application can be achieved. Implementing the directives of EWG, expert working groups, or ozone cell MOEFCs. Assisting the local ULBs, the urban local bodies, RERAs, Public Works Department, state urban ministries, and other linked agencies of building construction industry for the revision and creation of regulatory provisions for adoption of SPMP Stage 2 recommendations. Basically, all these recommendations have to be implemented, as I said about the recommendations. Most of the municipal authorities, the urban bodies, or even the state urban ministries, state and the central urban ministries, they have the urban rules in place. We have to basically see to it that those rules address the need for passive cooling or all these requirements. And for that, basic divisions or provision have to be revised. That is where the PIUs would come in picture. Expert working groups are basically meant to identify the sector and region specific implementation requirements, identification of relevant stakeholders, and providing guidance to CPIU or PIU on the domain or region specific implementation requirements. So if I know that for my cooling need, these are the steps I have to take. Obviously, one set of requirements would be developed for an example, a city like Raipur. Another set of requirements would be developed for a city like Thiruvananthapuram. Another requirement could be developed by Chennai. All these requirements would be different compared to each other, and somebody has to develop that. And that is EWG, and then it is implemented by the RPIUs. Now, what do? I have to have the stakeholders whom we are basically telling that these needs to be done. So the first stakeholder or the most important stakeholder is ozone cell MOEFCC, which would be working as a guiding force. Then comes MAHUA, then Ministry of Labor and Environment, Bureau of Energy Efficiency, DGET, that is the Directorate General of Employment and Training, DGFT, that is the Directorate General of Foreign Trade, Bureau of Indian Standards, Engineering Council of India, All India Council for Technical Education, Council of Architecture, State Ministries of Urban Development. Then comes CPW and state PWDs, various project authorities, RERAs, municipal corporations, industrial township authorities, smart cities, special purpose vehicles, CPSUs and SPSUs and other, including major corporates who are asset owning today, infrastructure owning corporates, Indian Polyurethane Association, which is basically one of the association body which produces polyurethane material. Then comes RAMA, that is Refrigeration and Air Conditioning Manufacturers Association. Then we need to address the educational part, and that is technical universities, engineering colleges, architectural colleges, and Vocational Training Institute. So as on date, on the proposal level, we have 24 different type of agencies who have to be sensitized and whose directions have to be taken or whose rules have to be edited. The rule and the requirements would be proposed by the SWGs, would be channeled by the Central Processing Unit, and then finally, the ministry or whatever department it is would be implementing that. Now, what EWG we are talking? We are talking about EWG, which is responsible for sensitization of passive cooling concept in the building construction industry. We are talking about an EWG established for sensitization of non-SCFC, low GWP alternatives in the building construction industry. An EWG for promoting application of passive cooling and non-SCFC or low GWP alternatives in building construction industry. Sensitization of India Cooling Action Plan in the building construction industry. Sensitization of Energy Conservation Building Code, that is ECBC, in building construction industry. Promoting green building concepts in building construction industry. Consolidated energy management for building life cycle. As on date, we have proposed 7 EWGs, but then there could be more, or some of the groups might be joined together. But then the basic concept is to provide these 7 directions of support to the entire building construction industry. Now, what are the actions a PIU has to perform? So first, let's look at the objectives. The objectives are enhancing the sensitization of passive cooling, enhancing the sensitization of non-SCFC and low global warming potential alternatives, promoting the application of passive cooling, non-SCFC or low GWP alternatives, promoting India Cooling Action Plan, promoting Energy Conservation Building Code, promoting life cycle energy management concept. So a PIU's objectives are these. Now, what are the action points we are proposing? Creation of regulatory provisions framework for adoption. Like, let's say I create, I'm like this, establish a PIU for a city, maybe Lucknow. That PIU, Lucknow PIU, would be talking about the regulatory provisions which are applicable to the region of Lucknow. It will be speaking with the municipal authority based in Lucknow, maybe the other urban agencies, maybe working with the local bodies, along with coordinating the activities with the central implementation unit, which would be working with the MOA or other bodies, and create a regulatory framework, create alter the current standards to include newer provisions, interact with the various ministries, departments, stakeholders for adoption of new provisions, develop the generic promotional materials, technical literature, technical competency requirements and standards, sensitization and training program structures, interact with the various stakeholders for securing financial assistance for the program execution, interact with various stakeholders for acceptance and adoption of the program and educational contents, conduct sensitization workshops, seminars and conferences, conduct educational training programs, conduct vocational training programs for development of artisans and professionals, promote the regulatory framework with the stakeholders, and assist various stakeholders in adoption of the framework. So if there are any cobwebs in the process, PIU would be assisting to remove that. So these are the action points of the PIUs. Now, here comes our invitation to all of you. Openings are available in different organs like EWGs and PIUs of the program management plan as advisors or as supporters of the whole process. Positions could be offered to individuals having adequate background, qualifications, and experience. Desirous individuals may submit their expression of interest to CIDC through email, that is cidc@cidc.in. A copy of this presentation will be available to you so that you can see if it is appropriate and you can contact CIDC for joining this major movement KIDC would be keen to have all the experience to come and assist the implementation of all this process. Operations of all program components shall be initiated after receiving the proper approval from the ozone cell. The proposal has already been given and it has to be started. At this stage, SPMP stage 2. Soon SPMP stage 3 will also be initiated. And the moment that comes in, we would like to migrate this whole process to SPMP 3 as well, because there many more things are coming in. The bottom line is that SPMP helps us to protect our world. And I invite all of you to come and join with us so that the world is protected as best as possible. With this, I will conclude my talk. With the growth of society, the demand for cooling energy is also growing at a fast pace. Supply of such quantum of energy could lead to extensive use of conventional energy sources, as non-conventional sources would not be able to cope up with the demands on their own. Solution to this environment challenge is to reduce the energy demand for the active cooling. So we go for passive cooling. Passive cooling methods are the best solutions in this case, as those create environment within the building envelope with lower active energy demands. Such design processes provide solutions through spatial arrangement of the building envelope and usage of appropriate materials to optimize the energy consumption over the complete life cycle of the structure. Use of ozone depleting substances, at other hand, is also harming the environment. To address these issues, Ozone Cell MOEFCC has taken a major initiative in the shape of SPMP stage 1 and stage 2, with HPMP stage 3 under approval. Actions still initial part of the SPMP stage 2 produce solutions by way of India Cooling Action Plan 2019, development of solutions linked with non-HCFC, low GWP alternatives for refrigeration, air conditioning, for active cooling systems, and many more ideas. The next step in this initiative is to implement such solutions aimed at reducing the demand for active cooling energy for the building construction industry. In the current initiative, CIDC is working with the MOEFCC and to promote the passive cooling and the use of non-HCFC and low global warming potential alternatives in building construction industry. Under the MOA, CIDC conducted a study and determined the needs of the industry and has recommended solutions from MOEFCC. Such solutions are being put up for due deliberations and upon approval shall be put up for implementation. This presentation discusses the study report and recommendations in brief. We invite the stakeholders to work with us to get the ideas implemented and protect our environment. I would like to thank you very much for patient hearing. On behalf of CIDC, we hope you would have found this presentation of use. I would look forward to receiving expressions from interested individuals for joining our initiative. Thank you very much.
Thank you, Dr. Niranjan Swarup, for the presentation. And the
Someone has to unmute. Or rather,
Yes.
someone has to mute.
Yes, now I'd like to invite Dr. Swarup for his concluding remarks.
Thank you very much, Dr. Kumar. And I was listening to the expressions made by all the speakers. And I'm so happy that the whole thing has now been put in a stage where we are now ready to go for the implementation. And basically, the real crux of the whole thing lies not merely about deliberating the things, but simultaneously implementing them. We know that the path is virgin. Not much has been done in this particular area. The deficiencies have been listed out. The solutions for implementations have been listed out. And I think it is for all the wise people who are here to come back, give their solutions, and be together and then make sure that we are able to implement the whole thing, not only for the welfare of the nation, but also for the welfare of the entire world. So I think with that kind of a clarion call, I would once again repeat what Dr. Niranjan Swarup spoke about. We require each one and every one of you to come and join hands. Please do that so that we can do the whole task in hand very effectively. Once again, I express my thanks to Ministry of Environment and Forest for having given us this interesting task, which has been now concluded this evening very satisfactorily. And I think this has prepared a blueprint for all of us to start acting upon. Thank you so much and very good day to all of you. Once again, I thank all the participants and all my speakers, and especially the representatives of Ministry of Environment and Forest, who had so elaborately expressed their views and told us what exactly is the way forward. So let us hope that we are in implementation mode. And with that, I hand it over to Dr. Kumar to conclude the session. Finish it.
Right. Thank you very much, Dr. Swarup. Very
Thank
kind.
you, sir. Thank you, sir. Thank you.
I'd like to thank everybody for this wonderful session that we had today. And we look forward to meet you all on the 10th, the conference that we are having from 10th to 12th, and the things that we shared you during the lunchtime. All the information is also on our website. You can go and visit there. And thank you once again, and I bid everybody a very good evening. Thank you. With this, we conclude this session.
Thank you very much, Suchita ji. Thank you ever so much. Thank you. Looking forward to seeing you 10th, 11th, 12th.
Yes.
Thank you.